Testing 1, 2, 3. Madam. Check Arabic. Testing 1, 2, 3. Test. Arabic, madam. Testing 1, 2, 3. Check. Check, check. Hey. Hey. Testing 1, 2, 3. Check 1, 2, 3. Okay, madam. Okay, I can hear you, madam. Yes. Yes, madam. English. Okay, okay, madam. Thank you. Hey, testing. 1, 2, 3. Check, check, check. Hey, hey. Testing. 1, 2, 3. Test. Check, check. Hey, sir. Okay. Test. Stay. Check. Ah, testing. 1, 2, 3. Test. What about the receiving? Well, we need also check it. We need to test also. Yeah. So we can hear it from here. Yes. Testing. 1, 2, 3. Test. Check, 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 check. Hey, 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 hey. Testing. 1, 2, 3. Test. You only tested. Check, check. Hey, testing. I need to
Test. Let's test. Yes. Yes. Okay.
check. Testing. 1, 2, 3. Test. Hey, hey, hey. Check.
Hey, check test, sound check, hey. Check, hey, sound check test. Hello, sound check, testing 1, 2. Sound check test.
شباب الميديا المايكات ما بينفعوا هيك. ممكن هذا ما بيزبط ريان. لا ما فهمته يكون على جنب هيك بيسكر الوش. كثير عالي نزله، كثير عالي. هذا
مع الكاميرا بنشيله.
لا ما تشيله بس يكون واطي بس يعني انه ما يسكر وش الMC. ريان
تبعنا الفكرة تمام.
هذا بيوطى اكثر.
وهو عشان الكاميرا عندنا.
أنا والله حكيت عليه قلت له انا عندكم استندات غير هذول.
والله الموجودين أهو.
والله قالوا لي عندكم استندات غير هذول.
والله ده الموجود. انت لو فيها انا
طيب اوكي هذا احسن من هذا.
انا ممكن.
ريان تلفزيون ريان TV. اوكي البرتو ما في ريان
موجودين.
وينه ريان؟ اخذ المايك ما بدك اياه؟ وين؟ كيفك؟ يا ستاند صغير يا ما بينفع. تحكي عربي انت؟ وين المصور اللي معك؟ قبلان فيه مسكر الوجه يعني بسكر الوجه.
سوري هو كله سوري.
داون 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 داون
عايز دعوة.
داون. ايوه
تمام.
بس someone short it's block you know.
طبعا يا باشا كده.
حبيبي Alberto can reduce little bit mid high and give me a little bit sound. Check yes better. Can give me more volume back speaker. Check بسم الله الرحمن الرحيم. ايه طيب من اول
وما بين بس هلا هيك بطل تبين لازم انت تتابع.
قدام ما فيك تحطه بالنص ما بينحط. لا بالنص ما بينحط لانه بيجي حدا قصير بفكر وشه. انت مصور صح؟ انت عارف كيف حطه هون؟
هو كان موجود هون. مشيت وحطيت المايك وجبت هلا CMB. حكينا على جنب.
هذا اعلى.
سهل. مش مربوط لك لوكال ولا مش لوكال.
بلش احكي بالسياسه.
اه
اوكي اوكي
هون اقتصاد.
هيك احسن. اوكي تمام. check yeah I think better. بسم الله الرحمن الرحيم.
بسم الله الرحمن الرحيم. سعادة السيد عبد العزيز بن ناصر بن مبارك آل خليفة، الأمين العام للمجلس الوطني للتخطيط. أصحاب السعادة، الحضور الكريم، السلام عليكم ورحمة الله تعالى وبركاته. تحت الرعاية الكريمة لمعالي الشيخ محمد بن عبد الرحمن بن جاسم آل ثاني، رئيس مجلس الوزراء، وزير الخارجية، يسعدنا أن نرحب بكم اليوم في منتدى الدوحة للبيانات من أجل الابتكار في التنمية المستدامة، والذي ينظمه المجلس الوطني للتخطيط على مدار يومين بالشراكة مع المؤسسات والمنظمات الوطنية والإقليمية والدولية. والآن مع كلمة سعادة السيد عبد العزيز بن ناصر بن مبارك آل خليفة، الأمين العام للمجلس الوطني للتخطيط، فليتفضل سعادته مشكورا.
شكرا ويعطيك العافية. بسم الله الرحمن الرحيم، والصلاة والسلام على أشرف المرسلين سيدنا محمد وعلى آله وصحبه أجمعين. أصحاب السعادة، السيدات والسادة، السلام عليكم ورحمة الله وبركاته. تحت الرعاية الكريمة لمعالي رئيس مجلس الوزراء ووزير الخارجية، يسعدني أن ألتقي بكم اليوم ضمن فعاليات منتدى الدوحة للبيانات، والذي يشارك فيه عدد من الشخصيات البارزة من الجهات الحكومية والمنظمات المحلية والدولية. نعكف حاليا في المجلس الوطني للتخطيط على إعداد الاستراتيجية الوطنية للبيانات والإحصاء، والتي من المقرر تدشينها بإذن الله خلال الربع الرابع من هذا العام. وتأتي الاستراتيجية الوطنية للبيانات والإحصاء لتلبية الاحتياجات الملحة في عصر الثورة الرقمية، وتماشيا مع خطة التنمية الوطنية الثالثة، نظرا للدور المحوري والهام للبيانات والإحصاءات التي تشكل العامل الأساسي لاتخاذ القرارات السليمة والمدروسة. إن الاستراتيجية التي نعكف على الانتهاء منها ترتكز على تطوير منظومة متكاملة لإدارة البيانات، وهي ليست أداة تنظيمية فقط، بل تمثل رؤية شاملة لقيادة أجندة البيانات والإحصاءات الوطنية، وتعتبر محطة جديدة نحو تحقيق التكامل بين مختلف القطاعات، بما يوفر المعلومات والبيانات الدقيقة اللازمة لدعم عمليات التخطيط والتطوير تماشيا مع رؤية قطر الوطنية 2030. إن ما نصبو إليه من خلال هذه الاستراتيجية هو بناء بنية تحتية متقدمة تتيح الوصول إلى بيانات عالية الجودة وآمنة، مع تعزيز آليات حوكمة البيانات وضمان الخصوصية والأمان. أصحاب السعادة، السادة الحضور، في منتدى الدوحة للبيانات لعام 2024 سيتم مناقشة مجموعة من المواضيع المتعلقة بالابتكار والتنمية المستدامة. إن الجلسات ستتضمن مناقشات حول البيانات والذكاء الاصطناعي ودوره في تحسين الأنظمة الإحصائية الرسمية، بالإضافة إلى استخدام البيانات الجغرافية المكانية في إدارة الكوارث. كما ستتناول جلسات أخرى كيفية تسخير البيانات لتحليل التقدم في تحقيق أهداف التنمية المستدامة. هنالك تركيز على تمكين الأفراد من اتخاذ القرارات المستنيرة باستخدام البيانات، وتناول أحدث الاتجاهات في التحليلات والبيانات لعام 2024. سيتم أيضا مناقشة الابتكار في مجال الإحصاءات الرسمية ومستقبل التنمية المستدامة في دول الخليج، وأهمية تحسين جمع البيانات لدعم الاستراتيجيات التنموية. أصحاب السعادة، السيدات والسادة الحضور، في ظل تسارع التطورات في عالم البيانات والتكنولوجيا، يأتي أيضا مركز التدريب الوطني للبيانات والإحصاء كمكون حيوي آخر ضمن المنظومة التي نقوم ببنائها، بهدف بناء القدرات في مجالات البيانات المختلفة. ويسرني الإعلان عن إنشاء هذا المركز، الذي سيكون بمثابة حاضنة لتطوير المهارات المتقدمة في إدارة البيانات وتحليلها، والتعلم الآلي، والتحليلات المتقدمة، وتقنيات البيانات الحديثة. إن مركز التدريب الوطني للبيانات والإحصاء سيكون محطة للتعلم المستمر وتقديم أحدث البرامج التعليمية والتدريبية التي تساهم في تطوير كوادر وطنية قادرة على استغلال قوة البيانات والإحصاءات، ولأننا نؤمن بأهمية الإبداع في مجال البيانات، يسرني أيضا الإعلان عن هاكاثون قطر للبيانات، وهي مبادرة طموحة تهدف إلى تشجيع المبدعين والمفكرين في قطاع التكنولوجيا والبيانات. إن هذه الجائزة ليست مجرد منافسة، بل هي منصة لتمكين الكفاءات الشابة وتحفيز التفكير الابتكاري والإبداعي لإيجاد حلول عملية للتحديات التي تواجه القطاعات المختلفة في هذا المجال. سنعمل من خلال هذه الجائزة وهذا الهاكاثون على تسليط الضوء على الأفكار الذكية التي تسهم في تحسين جودة الحياة وتعزيز الأداء في مختلف القطاعات. في الختام، أود أن أعرب عن شكري العميق لكل الشركاء الذين يعملون مع المجلس الوطني للتخطيط على تنفيذ هذه الرؤية، وبشكل خاص وزارة الاتصالات وتكنولوجيا المعلومات. نحن واثقون بأن هذه الجهود المشتركة ستقود إلى تحولات نوعية، بما يعزز من جودة الإحصاءات الوطنية والبيانات الوطنية، ويدعم مستقبل قطر كدولة رائدة في مجال البيانات والإحصاء. والسلام عليكم ورحمة الله وبركاته.
شكرا سعادة السيد عبد العزيز بن ناصر بن مبارك آل خليفة الأمين العام للمجلس الوطني للتخطيط. حضورنا الكريم، نترككم الآن مع استراحة لمدة 15 دقيقة استعدادا لأولى جلساتنا النقاشية لهذا المنتدى.
حلو.
السادة الحضور، سنبدأ أولى جلساتنا النقاشية خلال 5 دقائق. شكرا. السادة الحضور، والآن نبدأ معكم الجلسة الأولى والافتتاحية لهذا المنتدى تحت عنوان التنمية المستدامة والذكاء الاصطناعي، ويدير الجلسة الدكتور محمد عمران من معهد قطر لبحوث الحوسبة في جامعة حمد بن خليفة، فليتفضل مشكور.
Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, ladies and gentlemen. Welcome to this session on sustainable development with artificial intelligence. My name is Muhammad Imran, and I work as a senior scientist at Qatar Computing Research Institute at Hamad bin Khalifa University. It's my great pleasure to moderate today's important session, where we are going to explore the use of artificial intelligence techniques such as machine learning, large language models, remote sensing, and GIS to seek how we can improve the sustainability of countries or underdeveloped countries. So as we have witnessed recently, the innovation in artificial intelligence in the form of generative AI, large language models, and ChatGPT, you must have used now. So in my opinion, the potential to drive meaningful progress to achieve sustainability is greater than ever. So to discuss these topics, today we have 4 distinguished speakers from academia as well as from humanitarian organizations to discuss, the potentials of AI within this field. So without a further ado, let me introduce our first speaker, Dr. Muhammad Al-Tabaq. Dr. Al-Tabaq is a principal scientist at Qatar Computing Research Institute. He's leading the data science, data systems group since 2022. He holds a PhD in computer science from Purdue University in the United States. And today he'll be discussing Fanar, an Arabic-centric large language models that they are building in Qatar at Qatar Computing Research Institute. Dr. Al-Tabaq, please come on stage and talk about your work.
Assalamu alaikum, everyone. Good morning. So today I'll talk about large language model that we are building in QCRI called Fanar. So if we can have the slides online. So okay, sounds great. So all of you have probably heard about ChatGPT and Google Gemini and these large language models. So probably today I will shed the light how these models can actually benefit statistics and the statistics department and data authority in different countries. So Fanar is Arabic-centric large language model. And as you know, like a very brief idea about large language models, these are like AI models that are huge in size, and they have been trained on huge amount of data. All the data that you can imagine on the internet, whether it's text modality, audio, images, video, they are trained on all of these types of data. And that's why they can excel in so many tasks with very simple fine tuning and so on. So actually, this technology is a game changer technology in so many applications. And now different domains like the data statistics and so on, trying to figure out how I can benefit from this technology in my domain, on my data, and so on. Just to give you idea about the cost of building these models. So as you can see here, like getting closer to 2022 or 2023, you will see that on the x-axis, that now we are getting like Google Gemini, Google OpenAI, ChatGPT, and the cost on the y-axis, you can see it's getting across $100 million. So it's a huge amount and huge investment to just build one model, right? And then you can think about how to use it, how to benefit from that model. One model will cost over $100 million, right? So it's extremely complex process, extremely expensive. It requires certain types of hardware, GPUs, and so on. But here in Qatar, we decided to build one of these models. And the model is called Fanar. And the overview on Fanar is basically, it will be Arabic-centric model. And the reason is the Arabic data, the Arabic content on the internet is extremely limited. It's less than 1% or even less than 0.5% of the content on the internet, which means models like Google Gemini and ChatGPT, they are trained on this tiny amount of Arabic data compared to the huge amount of the English data. So basically, it's not really preserving the Arabic culture, the Islamic values. It's not well aligned with the different dialects in Arabic and so on. And that's why we are building Fanar. It's a family of large language models that are trained on a huge amount of data, around 1 trillion token or data words. Most of these data is in Arabic and different dialects in Arabic. It's a model that is being developed and implemented entirely from scratch here in QCRI in Qatar. And it is able to support these different dialects in Arabic. It's highly tuned components, starting from all the different components. Like you can think of these large language models as a huge system that has so many components. And we are tuning each of these components to the Arabic language and the Arabic values and culture and so on. This model, by the way, will be released in December. So I guess like 2 months from now, it will be released. It will be open to public and anyone can use it. It's actually a national project that is actually developed by QCRI, but we have a sponsorship and collaboration with different ministries in Qatar. MCIT is the sponsor and they are investing in the hardware and the infrastructure. Google is the one providing the infrastructure and the GPUs to us. And we have many collaborators like Qatar National Library, the Islamic Endowment, the Ministry of Islamic Endowment and Affairs in Qatar, Qatar University, and many other ministries in Qatar. And we plan to even expand outside Qatar. So maybe what's more important to the audience here is how these large language models can benefit data statistics. What are the use cases and so on? So there are actually many use cases. These huge large language models can benefit data statistics and the handling of statistical data. Two of these use cases, the first one is data cleaning and data validation. And the second one is data exploration and data querying. And maybe I will focus on the data exploration and the querying a little bit in the coming few minutes. So we have collaboration with the Planning and the Statistics Authority in Qatar here. So they have a very nice website. You can go to the Planning and the Statistics Authority, BSA in Qatar. They have thousands of tables and PDF files that have been created and manipulated over time by a large team from Planning and the Statistics Authority. And these PDFs actually contains a huge amount of structured data, as you can see it here. And that's not only specific to Qatar, to the planning and the statistics in Qatar, but we managed to get data from US Census, from the Pakistani Department of Statistics. Any country you go to on the website and you try to search for a statistics department, you will find on their website thousands of PDF files containing tables like this, right? These tables, what we call human-centric tables, they are designed for human consumption, right? As humans, you see how the table is formatted and organized. This formatting is extremely hard for machines to understand. Machines cannot answer questions on these tables. It's very hard. The way it is organized, it's really hard. But they are designed specifically for human consumption. As a human, when I read this table, I can see the rows and the column, the organization, and so on. Right? So from the end user, like statistical departments put huge effort to create these PDFs, create these tables. But actually, the usability and to query these tables is almost close to zero. And the planning and the statistics department right now, what they do, they have a manual process. Like if you have to query some of these tables, you need to send email to the planning and the statistics department. I need data about marriage in 2022, right? Or the number of departure and the arrival in 2020. You need to send the email, and someone manually will figure out which of these tables are related and can answer your question and reply back to you, right? So that's one example that large language models can be of huge benefit here. And what's even interesting, the data is not only in tables, the data is also in charts like this and different types of charts. Again, it's extremely hard to query these charts and tables in a systematic way. There is no way to answer these with current technology. However, large language models is one of the candidate technology, the new technology, that can actually understand these charts. They can understand these complex tables, right? All of these formats and so on, and they are able to answer your questions. So that will be huge benefit to statistical departments and handling of statistical data. And you can see all of these formats. There is no standard. Each table has its own format, its own structure. Machines cannot understand all of these, but large language models can. Right? You see all of these tables, structures, and so on. And that's not like new or something unfamiliar to all of the audience here. If you are working with the statistics, you are familiar with these tables and formats. So actually what we did, we built like a small prototype with the Planning and the Statistics Authority to leverage large language models to be able to query these tables and search these tables and so on. And we built what you see here. That's a very simple prototype, but it shows the potential, right? So basically, we took all of these PDF files, we extracted all of these tables, right? And we indexed them. We put them in index. Now you have an interface where you can ask a query or your question in natural language, right? So that's what you see in the right. So you ask your question in natural language. You don't need to be familiar with any programming language or anything. And then the large language model will search all its tables and its PDF files and so on, and will bring to you some candidate tables that can answer this question, right? That's all powered by large language models. So let's say the large language model decided this table is relevant to your question, right? Then you can pose other questions. You can ask very, very specific numbers from these tables. And again, there is no technology that can understand this structure except nowadays large language models. So you can ask a question like this. I believe the font is too small for you to see, but it's asking, I think, about the ratio between Qatari male and the Qatari female who are retired. So that's a very specific column in this table and very specific rows. But if you just give it to the LLM as an image, it will figure out which columns I need, which rows I need, and it will get the numbers and compute the ratio for you, right? So you ask in natural language, it replies in natural language over these complex tables that no other technology can do it right now. So that's one use case that I wanted to share with you about how large language models can be used in data statistics, in statistical departments, and it will be huge benefits for data exploration. So in summary, basically large language models can have huge benefit for a statistical department. It doesn't come for free. Large language models have their own challenges. Number one, all of you probably know it can hallucinate. It can generate wrong answer, but it has great potential as well. So how you can balance between the two? How you can use it in a safe environment to make sure it's producing the right answer, the right values, and so on. Some of the use cases, as we mentioned, data cleaning and data validation, that's core operation that any statistical department needs to do, data cleaning and validation, data querying and exploration. You can ask your question in natural language and it will reply in natural language as well, which is very beneficial to end users, right? So that's basically the key points and the summary I wanted to share with you regarding this technology and statistics departments. So thank you, and I am happy to take any questions.
So we take the questions
At the end. Yeah. Okay. Sure.
Yeah. Thanks, Mohammed, a lot for your wonderful presentation. So we will take the questions at the end of all 4 presentations. All right, so now let's move on to our second speaker. It's my great pleasure to introduce our second speaker, Ms. Minako Manomi, who is a senior advisor and head of the Risk Anticipation Unit at the United Nations Development Program Crisis Bureau in New York. Ms. Manomi has an extensive career with UNDP, including several years in Syria as deputy resident representative and team leader for socio-economic recovery. She has also served in UNDP Jordan, UNDP Nepal, UNDP headquarters, as well as with UNICEF. Today, Ms. Manomi will be talking about addressing complex risk for de-risking development. The floor is yours. Thank you.
Thank you very much for the introduction. As you can see, I'm not a data scientist, as many of you are. So I try to give the perspective of how data analytics, including AI, would actually support the SDG advances. So I will cover where we are in terms of SDG and then AI, and then also what we are facing. We see more and more risks, which are complex and compounded, and then to see how data analytics could actually address some of those complex risks. And then also as the last point, I want to touch upon some of the key gaps. So first, in terms of the UN and then AI, we have our framework as a Global Digital Compact that's frame our work on SDG and then also AI. We already see the documented evidence of increased case of AI deployment in SDG, but yet I want to highlight that we haven't documented the impact of AI deployment in SDG. So we see more and more increasing number of AI deployment. So perhaps one area that we want to see in coming years is actual impact of the AI or other data analytics deployment into SDG. So in terms of UNDP, we are positively embracing AI and then other data analytics in various SDG goals and then also area of the work. We work on, so those are the example of AI deployment in UNDP's work around SDG, nature, energy, and then also small island development. We see a lot of crisis response and the recovery work, and then as well as overall SDG. And then also gender. So again, we positively embrace AI and then its deployment into our overall work, and we see the increasing cases. So now, as I touched upon at the very beginning, while we see the emerging uses and then also development of the AI as a solution, one of the solutions to SDG, we also see the increasing risks, the risks of climate, conflict, natural disasters. They are all compounded. It has been becoming more and more complex, deepened, and protracted. And then all those different risk factors, for instance, climate is not just climate alone. Climate risks are linked to natural disasters. Often, climate also links with the conflict of the natural resource management. We see also gender aspect in it. We see health aspect closely linked to climate as as the temperature going up. So all those different risks are compounded, and then we try to see two levels of the risks. One is the systemic risks. As we all agree, risks are systemic. And then especially the structural one, either the national debt or macroeconomy, we see more structural risks, but at the same time, proximate risks, which are significant changes that we see in context. That could be disaster, that could be conflict. We often combine those systemic risks and the proximate risks, and then they are again compounded and then making it more complex to address. So right now, as UNDP and then as a development agency among UN agencies, we see de-risking, addressing risks in development is a key determinant of progression or regression of SDG. So this de-risking development as a key in SDG right now. And then I want to talk a little bit more about then what we mean by de-risking from the perspective of AI or other data analytics. So in this environment of complex risks, how does data analytics, including AI, support addressing complex risks in development? We take it as ecosystem approach, ecosystem where people, decision processes are, data and then information as input, and then often actions and then impact as outcome. So within this ecosystem, we take four main work stream as very important one. The first one is data and then platform. Second one is sense making. The third one is decision and then action. The last one is more enabling environment as impact measurement, learning, capacity, networking, partnership. And then I want to highlight, we don't necessarily start with data and a platform. I think it's important. I think we all agree that the use case is very important. And we want to know what kind of decisions and an action we want to make. That would inform the first work stream of data. So when we start with the data first, and then we just dig and scrape a lot of data without going towards any direction. So within UNDP, we try to see what are the main key actions and decisions we want to make, either to protect development gains or to address crisis and then prepare for crisis and then recover from it. So also one characteristic that we see is the major gap between sense making and the decision and an action, between 2 and 3. Based on data, we try to make sense with the combination of advanced data analytics, for instance, forecasting model, qualitative foresight, and then to make sense together with data. Then we try to inform decision But even if you have great analysis of the sense making, it's not that we can trigger decision making easily. It's not natural. And then there are different reasons in the different organizations. We also see a major gap of the mindset. The one who make the decision not necessarily coming from the data background. And then also we have this cognitive bias of not accepting higher and the complex risks, but rather accept simple and the lower risks. So there are some cognitive bias. We see the need of also behavior science to make sure the bridging the gap between sense making and taking action. Because at the end, the intent of all the work of the risk anticipation based on data analytics is taking actions and then creating the impact on SDG. So among those 4 work streams, I want to share some of the examples that we have. Under the data and the platform, the first work stream, we are currently deploying rapid data collections and then assessment in the crisis situation, including natural disaster and then conflict. We call it RAPIDA. Among the different actions for data collections and then assessment, we apply remote sensing, satellite imagery to quickly understand the damage level and then prioritize certain geographical area to further dig in. We also combine with the AI analytics to conduct the very immediate sense making out of either remote sensing and then also initial collections of data. So this is one example of AI application, and then we see more and more the technologies and the data analytics needed for damage assessment, because we often don't have access, physical access on the ground. So traditionally, we used to go on the ground, measure the impact, quantify the, for instance, the debris quantity, and then also the physical destruction. But more and more, it has become very difficult to access, but also it's very important to come up with the immediate assessment. So this is the area that we see more application needed. The second example is sense making, the second work stream. So as I talked about the complex risk lens, so when we apply this complex lens into data, but also understanding of the situation, we try to see the move from just the data, kind of static data, to be more dynamic and then to be more actionable in the sense making. So we try to have not only the past incident, the number of the incident and event, but we also try to combine forward-looking analysis, for instance, conflict forecasting model and real-time data analytics from social media monitoring, and then also news scraping. And then to combine all those, we try to have more dynamic, real-time, forward-looking. Therefore, we can make right decision to be prepared for response and then also recovery preparedness. So as I mentioned about the social media, news monitoring, so these are the experiment we are applying right now as part of the sense making. And then we see more and more of these use cases will be increased. But again, what I want to highlight is it's not that we are doing this for the sake of like nice data shabby work. It's really about addressing the gap of not necessarily provided in the current data stream. So we try to use first identify the gap and then come up with the data analytics and then apply as part of the overall risk analysis. So I want to finish with this slide of key gaps. So some of the gaps I mentioned. So the first one is data gap. I think we all agree that we still need to have more data, diverse, expanded data for more accurate AI-based analytics. Perhaps one is that we want to increase the quantity types of the data, but at the same time, data could be already available, but we are not well consolidating the different data in a way that we could make sense. So it's also the processing of the data, like where we store the data, and then how we consolidate, correlate data. So I think second one is how we process data. The third one is also localization of the data. I think we tend to centralize data, but it's also very important that we localize the data ownership and then the appreciate local knowledge and then localized data. So those are the data gap. The second gap we see is applying when we apply the system lens. We need to see the leveraging point of the interconnected different system. I think again with our all cognitive bias, we tend to be very simple, and then we try to take one system. But it's very important that the complex system create different interlinkages across the different system, for instance, food system, health system. And we need to identify this leveraging gap to see where is the point that we need to make the intervention to create the impact. So the connection gap still exists. And then I think understanding interconnection gap is important. The third one, I put 4 elements. The first one is about qualitative analysis need. I think we often rely on data, quantitative data, but it's always important to back with the qualitative data and then information, and then also local knowledge. And then sometimes quality data and then information could navigate where we should find big data, I mean quantitative data. So combining qualitative data information and the qualitative data is one important area to fill the gap between data and then decision. The second one to the fourth one is about the human aspect. So at the end of the day, the one who make decision, at least for now, not AI, but the human. I think human make decision. And then when we think about how human cognitive mind works, I think we identify some of the gap coming from the way we work in our mind, and then how the data coming out, and then how data is crafted in front of decision maker. So we want to see what kind of policy decision options available to inform data. So availing policy and decision cases and an option is to fill the gap between data and decision. The second one is a little bit more organizational. We actually self-criticize also in the UN, we have silo problem. I think different team works in a very different way. So it's important to have horizontal, vertical, and then horizontal integration to fill the gap between data and decision. The last one is about integrating human cognitive aspect and then data. I think many of you are data scientists. It's not so difficult for you to get the data and then understand what it means, but it's not always the case for decision makers. And then sometimes to address this cognitive gap and the bias, for instance, storytelling is very important. So I think we need to see the cognitive side, emotion side, if the intent is to make the decision, which is the case for SDG and then AI by the UN agency. So those human aspects seem to be quite important. And then as UNDP, we try to integrate this aspect as part of the risk anticipation work. With this, I want to finish my presentation, and thank you very much.
Thanks a lot, Ms. Minako. This was a great talk. Okay, my next speaker is Dr. Reem Suela, who is an expert in analyzing social network data for geolocation inference during disasters. Dr. Reem received her PhD degree last year from Qatar University. Her research interests are in information retrieval and natural language processing. Dr. Reem has published in top-tier international conferences and journals. Today, Dr. Reem will be talking about from social media to action, harnessing geospatial data and AI for smarter disaster management. Yes, welcome to.
Assalamu alaikum. Thanks, Dr. Muhammad, for the intro. Okay. Yeah, I'll use it. لعل هذا العرض هو العرض الوحيد باللغة العربية في هذه الجلسة. ما أتحدث عنه اليوم هو أحد أبرز التحديات في مجال إدارة الكوارث. أتناول هذا الموضوع من محورين. المحور الأول هو نوعية البيانات المستخدمة، والمحور الثاني هو إعمال الذكاء الاصطناعي لأداء بعض المهام في هذا المجال. لابد من الإشارة إلى أن ما أعرضه اليوم هو نتاج أو لمحة بسيطة عن نتائج الأبحاث التي قمنا بها خلال السنوات الماضية في جامعة قطر تحت إشراف دكتور تامر السيد من جامعة قطر والدكتور محمد عمران من معهد قطر لبحوث الحوسبة. بما أننا نتحدث عن الذكاء الاصطناعي، إذن لابد من معرفة ما هي الخطوات الأساسية لتوظيف الذكاء الاصطناعي في أي مجال. الخطوة الأولى هي تحديد مصادر البيانات وتجميعها. الخطوة الثانية هي تعريف المهام التي نود إحلال البشر بالذكاء الاصطناعي فيها أو دعم أعمالهم ومهامهم. الخطوة الثالثة هي بناء أنظمة الذكاء الاصطناعي لأداء هذه المهام، وأخيراً تشغيل هذه الأنظمة على أرض الواقع. سيدور هذا العرض حول هذه الأربع خطوات في مجال إدارة الكوارث، بدءاً بالبيانات. البيانات التقليدية لإدارة الكوارث هي البيانات المستخرجة من أجهزة الاستشعار عن بعد، أو بيانات صور الأقمار الصناعية أو المسوحات الميدانية التي يجمعها العاملين في هيئات الإغاثة والعمل الخيري، أو حتى المكالمات التي يقوم بها الأشخاص المتضررين في استخدام خدمات الطوارئ لطلب المساعدة أو حتى طرح بعض الأسئلة. جميع هذه المصادر أثبتت جودتها واستخدمت على مدى السنوات الماضية، لكنها تعاني من بعض أوجه القصور. الأول فيها هي التكلفة، حيث ليس جميع الدول النامية تستطيع استخدام أو شراء أجهزة الاستشعار عن بعد. المشكلة الثانية هي الخطورة، حيث جمع أو تجميع البيانات خلال الكوارث قد يعرض العاملين في مجالي الإغاثة والعمل الخيري قد يعرض حياتهم إلى الخطر. المشكلة الثالثة هي السلطة، إذ نحتاج للمرور بالعديد من الإجراءات وأخذ تصريحات لتجميع بيانات من الأشخاص المتضررين والمتأثرين بالكوارث، مما يؤدي في النهاية إلى التأخير في الاستجابة وإدارة الكوارث. إذن لجمع بيانات تساعدنا في إدارة الكوارث بشكل فاعل وبكفاءة، نحتاج إلى تجميع البيانات أو مصدر يحتوي على بيانات من الأشخاص بشكل مباشر بأقل تكلفة، بدون تعريض حياة العاملين في جهات الإغاثة والعمل الخيري للخطر، وبأقل تعقيد لبدء عمليات الإغاثة بأسرع وقت. جميع هذه الشروط تندرج أو تحققها منصات التواصل الاجتماعي. ما أركز عليه هو منصة إكس، كون منصة إكس هي أحد المنصات التي يستخدمها الناس لرصد ما يجري حولهم خلال الكوارث. هل فعلاً منصة إكس تحتوي على بعض المنشورات المهمة والمفيدة لإدارة الكوارث؟ عملنا بحث بسيط بمراجعة بيانات التي يشاركها الناس خلال عدة كوارث حدثت في الوطن العربي. أعرض بعض النماذج أو الأمثلة لهذه المنشورات. في المنشور الأول الذي يشاركه المستخدم يوثق حالة تدمر جسر بعد سيول الأردن التي حدثت عام 2018. المثال الثاني لتغريدة أخرى يشاركها الشخص لتوثيق تحطيم برج كهرباء بعد سيول حفر الباطن في المملكة العربية السعودية. هناك العديد من الأمثلة على المعلومات التي يمكن استخدامها في إدارة الكوارث، أعرض الكثير منها على الشاشة. إذن بعد تحديد مصدر البيانات وهو منصة إكس، الخطوة التالية هي تعريف وتحديد المهام التي نريد بناء أنظمة ذكاء اصطناعي للقيام بها. هناك العديد من الأمثلة كالكشف عن الكوارث والحوادث، أو استخراج المعلومات المفيدة كالأمثلة التي عرضناها، أو عمل تلخيص لما يجري على أرض الواقع من خلال استخدام منشورات منصات التواصل الاجتماعي، أو الكشف عن المعلومات الخاطئة التي تنتشر تحديدا خلال الكوارث. الأهم من ذلك كله هو عرض هذه المعلومات في سياقها الجغرافي، وهو ما أركز عليه. هل البيانات الجغرافية مفيدة خلال الكوارث؟ لابد من الإشارة إلى أن هناك مجموعتين من المناطق الجغرافية، إما المناطق الواسعة وتلك المفيدة لرسم نظرة عامة عما يجري حول الكارثة الحالية، مما يساعدنا في إدارة عمليات الإغاثة وتقييم الأضرار. مثال على هذه الخريطة التي أنشأتها منظمة UN أوتشا بعد فيضانات السودان، والتي تعرض المحافظات الأكثر تضرراً بعد جمع بيانات عن الأشخاص المتضررين والمنازل المدمرة أو المتضررة بشكل جزئي. النوع الثاني من البيانات الجغرافية هي النقاط الجغرافية المحددة التي تساعد في إعداد تقارير تفصيلية عما يجري على أرض الواقع. مثال على الاستفادة من هذا النوع من البيانات الجغرافية هي هذه الخريطة التي أنشأتها أيضا منظمة أوتشا لعرض الشوارع المدمرة بعد زلزال حدث في النيبال عام 2020. بعد فهم أهمية البيانات الجغرافية، من أين نستخرج البيانات الجغرافية من منصة إكس؟ هناك العديد من الأماكن كموقع المستخدم الذي يعرضه في ملفه التعريفي على منصة إكس، أو موقع المنشور. كذلك يمكن استخراج هذه البيانات من النصوص كنبذة المستخدم في ملفه التعريفي أو نصوص منشوراته. بعد استخراج جميع هذه البيانات يمكننا تحديد موقع المستخدم في منصة إكس، أو تحديد موقع منزله، أو تحديد موقع الموقع من أين شارك منشوراته، وهذا يساعد في تتبع تحركاته خلال الكارثة. يمكننا كذلك تحديد السياق الجغرافي للمنشورات بشكل عام، أو استخراج أسماء الأماكن من النصوص ثم ربطها بمعاجم أطلسية إلكترونية تحتوي على معلومات كثيرة عن هذه الأماكن، مما يساعدنا في نهاية الأمر إلى تحديد هذه المواقع على الخرائط. أركز على المهمة الأخيرة لشرحها بشكل أكثر. لنفترض أن لدينا مجموعة من المنشورات من منصة إكس تتناول عاصفة التنين، وهي أحد الكوارث التي أثرت في العديد من الدول العربية عام 2020. هذا أحد المنشورات التي شاركها أحد الأشخاص خلال هذه الكارثة لتحديد أحد الملاجئ المتاحة للأشخاص المتضررين في مصر، تحديدا في القاهرة. المهمة الأولى هي بناء نظام ذكاء اصطناعي يساعدنا على استخراج أسماء الأماكن الموجودة في النص. بالتالي سيكون النتاج هو القاهرة، مسجد الفتح، ميدان رمسيس، القاهرة. الخطوة الثانية التي يؤديها نظام الذكاء الاصطناعي هي ربط هذه الأسماء التي على الشاشة بأخرى موجودة ومعرفة حقيقية في معاجم أطلسية إلكترونية. هذا يساعدنا في استخراج المزيد من المعلومات عن هذه الأماكن كعناوينها أو حتى إحداثياتها الجغرافية، بالتالي تحديدها على الخارطة بشكل أسرع وأسهل. بعد تحديد مصدر البيانات وتعريف المهام التي نود بناء أنظمة ذكاء اصطناعي لتأديتها، النقطة الثالثة هي تأكد من أن البيانات التي نملكها تساعد في بناء هذه الأنظمة. لهذا الهدف بنينا مجموعات إدريسي التي تحتوي على الآلاف من المنشورات على منصة إكس، التي جمعت خلال العديد من الكوارث الطبيعية والتي من صنع الإنسان كالتفجيرات في الوطن العربي لسوء الحال. هذه الكوارث حدثت في أكثر من 14 بلد يتحدث اللغة الإنجليزية وأغلب الدول العربية. تتناول هذه المنشورات العديد من المعلومات المهمة كتقييم الأضرار أو نزوح أو بعض النصائح التي يشاركها الأشخاص فيما بينهم لدعم بعضهم البعض خلال الكوارث. تمكنا من تحديد ما يزيد عن 21 ألف موقع جغرافي باللغة الإنجليزية وما يجاوز 5000 موقع باللغة العربية. تمكنا من ربط ما يزيد عن 60% منها بمعاجم أطلسية إلكترونية. أنواع هذه المواقع تشمل بلدان ومحافظات، مدن وأحياء، شوارع، وحتى معالم من صنع الإنسان أو معالم طبيعية. بعد إعداد البيانات لبناء وتطوير أنظمة ذكاء اصطناعي، الخطوة التالية هي بناء هذه الأنظمة. لأداء المهمة الأولى لاستخراج أسماء الأماكن من النصوص، استخدمنا نموذج اللغوي بيرت الذي يعتمد على صياغ الكلمات من حيث الصياغ اللغوي أو النحوي. وتمكنا من إثبات أن النموذج الذي أنشأناه مقارنة بجميع النماذج المتاحة في وقتها كان يقدم أداء منافس. باللغتين العربية والإنجليزية باستخدام بيانات ما يزيد عن 25 كارثة طبيعية ومن صنع الإنسان. للمهمة الثانية وهي ربط لبناء نموذج ذكاء اصطناعي للمهمة التالية وهي ربط أسماء الأماكن المستخرجة من التغريدات بأخرى في المعاجم الأطلسية. استخدمنا ذات النموذج اللغوي وهو بيرت، وقد حقق أداء منافس مقارنة بجميع النماذج المتاحة في وقتها. بعد بناء هذه الأنظمة لابد من تشغيلها على أرض الواقع للتأكد من أدائها في الكوارث الطبيعية. قام فريق أيدر في معهد قطر لبحوث الحوسبة بدمج نموذج استخراج أسماء الأماكن ضمن وحدات معالجة، العديد من وحدات المعالجة التي تهدف إلى الاستجابة للكوارث. بناء على ذلك تم تشغيله على الكثير من الكوارث الطبيعية الحقيقية الواقعة مثل فيضانات السودان. سيتحدث عن هذا بمزيد من التفاصيل دكتور محمد عمران في عرضه. بهذا نكون وصلنا إلى نهاية العرض. شكرا جزيلا.
Thanks a lot, Dr. Reem, for your wonderful presentation on this topic. Now we move on to our last presentation, which will be delivered by myself. So I'm going to talk about our work at Qatar Computing Research Institute, where we use artificial intelligence to develop innovative technologies for various social good problems. So my name is Muhammad Imran, and I work as a senior scientist. I lead a crisis computing group at QCRI, and we have been working in this space for the last 10 years. So in terms of the technologies that we focus on, or the data sources and the kind of systems that we have developed so far, we mainly focus on social sensing data. So this is the data coming from various types of social networks, right? So this data is readily available right after an emergency or a disaster. And as Dr. Reem was also talking about social media data, so you have an idea about people during disasters, talk about damages, talk about their needs, and the kind of help they need, and so on and so forth. So they post on social media platforms such as Facebook, X, YouTube, and so on and so forth. And then we also use remote sensing sources like satellite image processing. And the kinds of systems that we have built in partnership with several United Nations agencies include artificial intelligence for disaster response, crisis NLP, global landslide detector. So today I'm going to show you a few of these systems and how we deployed this system with our partner organizations during real world emergencies. So I'm going to start with one of our recent deployment with UNDP in Pakistan, when the country faced a large scale devastating flooding situation in 2022, where millions of people were affected, and almost 1/3 of the country was submerged. So both the NGOs as well as government organizations did not have any clue where to focus on, where to dispatch the aid, right? So they need to first identify the areas which are most affected, where the most affected population live, and what kind of help they need, and so on and so forth. So this is where we help them with technology. So we had 5 fundamental questions that we wanted to help them with. So the first one is, what is the extent of flooding, right? So which districts, which cities, which provinces are flooded? How many people are exposed in those provinces? And what are their urgent needs? And the kind of damage incurred due to the flooding situation. So as I said, we mainly rely on non-traditional data sources, including social sensing, remote sensing. So here, for this particular deployment, we fuse these data sources together to process them, using a series of artificial intelligence models. I'm not going to go into the detail of this system, but superficially, we downloaded more than 1,600 satellite imageries that covering the full entire country. We had millions of Twitter messages gathered, collected from affected areas, as well as more than 400,000 images. And then we use bunch of geospatial data, the population statistics, the population density, the infrastructure type, and so on and so forth. So here is our first analysis that highlights the flood extent only using remote sensing sources. So we had satellite imagery covering the entire country, and we had snapshots taken after every week, and then ran our models to identify which districts, which areas in Pakistan are more flooded, or what is the flood extent. So here you can see the red color indicates the flood extent. The blue color indicates where the permanent water is, like the rivers, the water bodies, and so on and so forth. And you can see also the weekly progression, the distribution of flood extent, and then on the left lower corner, the distribution of flood extent across major provinces in Pakistan. And from here, you can immediately assess which districts are more flooded, right? Now, our second question is, okay, we now know that certain districts, certain provinces are affected. How many people are living there? And out of those people, how many are exposed to those flooding? So on the left side, we use the geospatial data sources and the flood extent that I showed you earlier to identify the uh, the most affected provinces, districts in this case. So each circle here in this diagram represent one district in Pakistan, and the color intensity represents how severe it is flooded. The radius of the circle represent the proportion of the population. So from this diagram, authorities can immediately understand the bigger districts in terms of population, in terms of flood extent, and the people exposed. So this was hugely useful for them to understand. We even did a fine-grained analysis of these most affected districts. As you can see, the grid-based analysis on the left lower side, where we had 5 by 5 kilometer grid in those districts to identify how many people are living in each cell and whether they are exposed or not. So this enables very fine-grained, high-resolution decision-making processes that they have to do. Now, this is not enough. We further dig down to identify within those hard-hit districts what is the distribution of gender, right? How many females are affected, how many male children, elderly, and so on and so forth. This is useful for organizations like UNICEF. So UNICEF would be interested in, focusing on districts where the children are more affected. So from this analysis that we did, they can immediately understand the from this chart. You can see that on the x-axis we have all the districts in Pakistan, and the different circles in different color represent different gender. And from here you can see that districts where the children are most affected, for example, right, and so on and so forth, and you can inform your decision making processes. Now, this is very important. All earlier charts and analysis that I showed you are based on satellite imagery. Now, as I said, that we also use social media data, like the textual messages that people post, as well as images that people post. So this heat map is based on the millions of messages that we collected by the posted by the people who are in the affected areas, to understand what are the needs, what they actually needing in terms of shelter, medicine, certain type of food, water, blankets, electricity, money. So we were interested to know that. So we did this, analysis based on, we ran, machine learning models, a series of machine learning models to identify what are different needs from within these affected areas. And on the y-axis, the vertical axis, you can see we had a long list of needs. I'm showing you, a proportion is a snapshot of the top one, and on the x-axis, these are the districts. So from this heat map, one can immediately identify the need to district combination, right? So you can see that which districts are more in need of certain type of goods or help, and so on and so forth. So this was hugely useful for our UNDP and Pakistan government. Now, in addition to that, we also analyze the images that people post from those disaster areas. So this is a snapshot of some images that we process through machine learning models, computer vision models, to identify whether the disaster damage scenes are coming from residential area or from the road and street, or different other types of infrastructure. So this is also useful for different agencies in the country to focus on, if there are more reports of damage to roads, streets, bridges are emerging, then they need to focus their help towards those areas. And certainly, if more damage reports are coming from residential area, they would understand accordingly as well. So with this analysis, we created this holistic map of the country, and we help them identify in terms of textual report, in terms of needs, damage reports coming from images, and so on and so forth, for the whole duration. And this hugely helped them identify, on daily basis or weekly basis, which provinces or districts to focus on. Now I'll move on to another use case, which is one of our, like UNDP has this building damage assessment use case that they do right after a disaster to identify, the number of buildings damaged in an area after a hurricane or a earthquake, and so on and so forth. So we have been helping them for so long. This is one of the deployment in Beirut after Beirut explosion, where we deployed our systems to identify damage reports, within hours. So we process more than 100,000 images people posted on social networks to identify scenes that show damages to buildings and other infrastructure. We collaborated with FEMA and CERT communities in the US to help them during Hurricane Dorian assess the damage as the hurricane was making landfall to different states as it was moving. So this was again hugely useful for these organizations to identify damage incurred due to hurricane in real time. So one of our recent deployment was also Turkey city earthquake, where we helped UNDP again to understand various types of issues that people are posting on social media. Here you see that these are the real messages people posted right after the earthquake on social media, and see that how useful they are. If someone can, collect them, process them, analyze them, act upon them, right? So these messages include requests for shelters and kitchen supplies and missing people and so on and so forth. So basically, we developed an application for UNDP to identify three types of data. One is the distribution of missing people reports coming from social media. The second is shelter request right after earthquake. Shelter is the most important thing that they would request. So the houses were destroyed, so they were requesting tents and other types of shelter. And then lastly, the damage. So these maps, show the distribution normalized by the population in those respective cities in Turkey, which were hard hit. And this has been hugely useful for them to get such a useful data in real time. I'm not talking about preparing this after 1 month or 2 months. I'm talking about preparing such maps within hours after a disaster. All right. So with that, I'll thank all of our speaker, and now we move on to the audience question. We have some time to take your questions. Feel free to ask your question to our speakers. Yes, please. Do you have mic?
Assalamu alaikum wa rahmatullah. Ubad Diab, Minister of Labor. Firstly, thank you for moderating a wonderful session, Dr. Imran, and pleasure to see you again and to see the work that we worked on with AIDER and tracking attacks on education back in 2019. Thank you specifically to the panelists from the UNDP. Prior to working in the Ministry of Labor, I had the opportunity to work with the United Nations, specifically the OCHA Center for Humanitarian Data. During my time there, I focused on centralizing a platform for humanitarian data. So my question to you is, one challenge I noticed was the gap in fully capturing local context and cultural nuances while balancing the data being fit for purpose, which directly connects to the point you made about the importance of localizing data. In your view, how can we further develop mechanisms to ensure data collection analysis remain culturally sensitive and reflective of local realities, especially in complex risk environments, while balancing it being fit for purpose? Thank you very much.
I think yes. Thank you very much for your point. This localization of data is actually quite emerging, the concept and then trend right now. So I think there are different aspects to think around this localization of data. Again, I would go back to the intent of the data collection, and then I think that should also reflect on why and then how we localize data. I think one intent is we want to have context and then context sensitive programming after the data collection. And then when we conduct context sensitive programming, that means we want to engage with the diverse background of the population group at the local level. Therefore, this data collections at the local level or localized data collection to analysis should actually engage with the local population. And then not necessarily the one who is prominent on data analytics, but the ordinary people And then I think qualitative aspect of the local population is indeed important to also back the data analytics. So it should be the process kind of backward from the intent of context sensitive programming / decision. And then it's all like coming back all the way to the data collections. And then I think it's also around the fundamental questions on who owns the data. I think we are quite cognizant that we conduct needs assessment all the time, going to the same population, asking again, same question, like raising the expectation of the also support and then aid. So I think it's important to really change the paradigm of like who owns the data and if the ownership is with the local population. And then I think our attitude and an aspect of engaging with them would be also shifting around. And I think that should inform actual decision and then also programming for context sensitive and eventually to really empower the local populations and then coming back from the data collection. So it's really about who we engage, who make the decision, who owns the data. I think it's quite ethical question around that as well.
Yeah, other questions? Yeah, please go ahead.
Thanks very much for this nice session. Question to Dr. Mohammed from you, Imran, from an naive question from an outsider. For the determination of the level of damage of the buildings, who decides about that level? Is it just the II, or you have an architect who decides? Or
Yeah. So that's a very good question. And we had difficulty following the damage severity scale established by various international organizations. So the one that we modeled in our machine learning model is coming from Red Cross. So Red Cross has a 3-scale damage severity level. It starts from little to no damage, to mild damage, to severe damage. And so the severe damage, examples of severe damage is non-drivable road, non-livable building, or non-possible bridge, totally destroyed infrastructure. The moderate damage category would include houses which are partially livable. For example, their windows are cracked, or maybe half of the roof is collapsed, or there are cracks in the buildings, and so on and so forth. And little to no damage could be due to wear tear or due to small other factors. So in our experience, modeling these 3 categories of damage, whether it's a severe damage, moderate damage, or little to no damage, was very difficult for machine to teach. As a human, you can have your opinion to say that this is severe or mild, but machine giving this idea to machine was very hard for us to overcome. So to resolve this issue, we consulted and asked help from many experts in the world to help us differentiate severely damaged infrastructure images to moderately damaged infrastructure images. So these are the 2 categories which really are closer in terms of their modeling class. So with the help of thousands of images, in fact millions of images that we have used to train our models, we were able to confidently say that to a certain extent, like our model accuracy is around 78%. So to a certain extent, we can say that what model is saying is correct or not.
Good morning. My name is Musa and I'm from Doha Institute for Graduate Studies. Actually, following the question of my friend here, for the UNDP speaker, actually, he speak about how to use the AI for the crisis management. But for the countries that are really facing long-term conflicts, I think I don't know if you're still using the same approach, one size fit for all, like countries that are really facing long-term conflicts, it is really difficult to have access for data there. And sometimes the data will be mobilized by different conflicted factions. How you are using different approaches to deal with these issues that are very important in the conflicted zones. So this is one. The other thing, that what are the strategic approaches that can be designed to enhance resilience in these areas, especially the conflicted zones?
Thank you very much for this question. Indeed, many conflicts are protracted, especially in the region of Arab states, but also in African continent. So it's not just emerging changes that we are detecting. I think they're the reason why we see this complex lens to understand the system level risks is important, is precisely we want to see the also structural risks, not only the proximate risks. Structural risks in the sense also disparity in the region or inequality in the system. I think those should be really looked into in addition to proximate risks. And then those are not necessarily coming from data point, as you mentioned. I think this combination with the qualitative analysis, local knowledge is quite essential. But yet, we also want to have this data backing. And then, as you mentioned, data is indeed quite political. And then this it goes back to this localizations and then ownership of data is also coming around this data being political in nature because it carries certain messages in any kind of data. So I think one approach that we apply is really triangulation of not necessarily only data and then also qualitative side, but also how much we can engage with the different diverse backgrounds population through the even data collection and then linking to some of the decision-making processes. Because I think it's also the gap between data or the qualitative information analysis to the decision. I think each decision should be also taken with the participations of the local community. And then I think that's the quite essential in also resilience building in the protracted the context. So I would say localization, local ownership, participation, and then those should be really across the qualitative and the quantitative data element, as well as the decision making as well.
Hi, myself Mohammed from Qatar Central Bank. I was curious on the Arabic LLM. So we do understand a lot of challenges today, even to translate Arabic document, we have a lot of issues, but quite excited to see that kind of progress you're making on it. So my question to you, what's your plan for the future? I see you're making available a POC on the PSA website or MPC website. So is there a time that we can expect that's going to be available like ChatGPT? I mean, today, as you mentioned, only less than 1% of Arabic materials is available on the this kind of LLM model. So we do definitely feel like biasness in the answers, mostly coming from Western view. So the first thing, like very curious to see when we are going to get a general available version of your model or something similar around the world, like FANAR public version. And the second one, do you see in near future we can make use of our knowledge base, which is inside to the organization, and make use of your model and enhance it for our purpose internally? Thank you.
Yes, absolutely. So, thank you for the question. So, basically, regarding FANAR, Arabic large language model. So, right now we are in the phase of what we call FANAR 1.0, and that's the plan is to release FANAR 1.0 in December, as I mentioned. So that will be a generic model that will be open for public. But in FANAR 2.0, where we focus like mostly in the coming year, like 2025, it will be mostly in building use cases on top of FANAR 1.0. And for that, we will approach different ministries in Qatar and even outside Qatar and see how we can fine tune FANAR to specific use cases, specific types of data, and so on. For example, if we take the Planning and Statistics Authority, they have this special type of these PDF documents and tables, charts, and so on. So large language models have shown great potential in understanding and processing these data. But still, there is a gap. There are cases where they fail and they cannot process these tables and structures and so on. So when we start thinking about specific use case and fine-tuning FANAR for this specific type of data, we believe it will do much, much better and it can really benefit these organizations. So we take it one step at a time. Until December timeline, it's FANAR 1.1.0, which is generic model. Then in the coming year, we will focus more on the use cases and the specific ministries to target. Thank you.
So first of all, thank you all for your great presentations. I'm Hassan from Ministry of Environment and Climate Change. My question actually is for Dr. Muhammad Tabbakh. First of all, how you train your model to like adapt or to deal with Arabic culture and values? So how it have like a clear background about Arabic users? Second, how it deals with like dialectical variations. So is it only for like standard Arabic or it can deal with like modern Arabic? Thank you.
Yes, actually, these are two core points why we are building FANAR. So basically, as I mentioned, like ChatGPT, Google Gemini, and so on, when you try these large language models, they understand Arabic to some extent and they can reply in Arabic, but they are lacking the Arabic culture, the Islamic values. So basically, because they are trained on huge amount of data, which is coming from the Western side, and very, very little data coming from the Arab side and the Muslim side, and so on. So that's what we are changing in FANAR. So FANAR is being trained on 1 trillion words or tokens. Large majority of these data is highly selected and curated Arabic content. And so FANAR is reflecting actually much better compared to ChatGPT, Google Gemini, is reflecting the Arabic values, the Islamic culture, and the traditions, and so on. And one of the efforts we are doing right now, which is lacking in other large language models, is building specific benchmarks to measure this cultural awareness and the ability to answer in dialect Arabic language. So most of the written Arabic is MSA, which is the modern standard Arabic. But when people speak, usually it's in dialects, right? Like whether it's Egyptian dialect, Gulf, or Levantine, so different dialects. So FANAR will be able to understand these dialects and respond in the same dialect. That's how it is trained. Okay. Thank you.
We may have time for one or two more questions. Yes, please.
Thank you. I just want to ask two questions. First one is the Arabic about Arabic LLM. Does the system hallucinate? Let's say when a user research for a data from your dissemination channel, let's say in the COVID time, there is a missing item in your dissemination, then the system hallucinates for this missing item. And the other question is for the social media messages. And do you detect scam or troll messages in the social media, and how do you handle that messages? Thank you.
Right. So I'll answer the first question regarding the hallucination in the large language models. So hallucination in large language models, I would say it's inherent feature and inherent characteristic of the model. So it will hallucinate, but how you can minimize this hallucination, there are many ways to do it. But to prevent it to reach zero level, I would say no. Most LLMs, even the strongest ones like ChatGPT and Google Gemini, there are cases where they hallucinate. But in Fanar, for example, because we really care about, as we mentioned, the Islamic, let's say, Islamic values, Islamic content, and so on. So there is no room for hallucination in Islamic content. It's not allowed for the model to generate new ayahs or new hadith. That's a red line, right? So for that, we are taking precaution measures. We are doing like many levels of verification, authentication, uh, validation using RAG technology, all of these to prevent to zero level hallucination in specific areas, right? Like specific domain or content. But in general, it will still find its way to hallucinate in certain other areas. So that's something we cannot control to zero level. Thank you. For the second one is for.
You hear me, right? So this is one of the biggest challenges that we face when we deal with social media. It contains lots of garbage data or low quality data. And we're assuming that we have a component, a filtering component that we use to get rid of all of that content before we use it for disaster management. So this is like the answer, inshallah.
Okay, one last question. Yeah.
Yeah, very quick one. How much do you rely on the availability of internet to collect the data? Because during disasters, sometimes in many regions, the internet may be down, so you cannot collect any social media, nothing.
Right. So, of course, the availability of internet is the fundamental assumption of all the work that I showed and Dr. Reem showed. If there is no internet, what we have seen, some NGOs, some countries would rapidly establish some SMS free code, right? So, for example, in Zambia with UNICEF, we tailored, customize our system to receive not social media messages but SMS messages, right? And then we use this same pipeline to process those messages to travel from sense making, data processing to decision making. So internet is the fundamental requirement. Otherwise, it's of course we cannot operate.
We have reached the end of our Q&A session. Thank you, Dr. Muhammad Amran, and your distinguished guest. السادة الحضور، نشكر المتحدثين في ختام الجلسة النقاشية الأولى من منتدى الدوحة للبيانات. والآن ندعوكم إلى استراحة لمدة 30 دقيقة، ومن بعدها سنكمل جلساتنا النقاشية لهذا المنتدى. شكرا جزيلا لكم. الحضور الكريم، سنبدأ ثاني جلساتنا النقاشية لمنتدى الدوحة للبيانات خلال 5 دقائق. شكرا. In 5 minutes. الحضور الكريم، نرحب بكم من جديد، ونبدأ الجلسة الثانية تحت عنوان البيانات والذكاء الاصطناعي. ويدير الجلسة سيد ناصر صالح المهدي من المجلس الوطني للتخطيط، فليتفضل مشكورا.
بسم الله الرحمن الرحيم، الحمد لله رب العالمين، الصلاة والسلام على سيدنا محمد وعلى آله وصحبه أجمعين. السلام عليكم ورحمة الله وبركاته. الحضور الكرام، جلستنا إن شاء الله الثانية بتكون عن البيانات والذكاء الاصطناعي. طبعا مما لا شك فيه يعد تبني الذكاء الاصطناعي والتعلم الآلي من قبل الأجهزة الإحصائية خطوة حاسمة نحو مستقبل إحصائي أكثر تقدما وديناميكية. طبعا أصبح من الممكن الآن تسخير الذكاء الاصطناعي لتحليل كميات ضخمة من البيانات بشكل أسرع وأكثر دقة، مما يمكن الأجهزة الإحصائية أو الجهات المنتجة للبيانات من تقديم تقارير ومؤشرات إحصائية محدثة في وقت قياسي. ومنها على سبيل المثال يمكن استخدام تقنيات التعلم الآلي لاكتشاف أنماط وتوجهات خفية في البيانات والتي قد لا تكون واضحة بالطرق التقليدية، وكذلك يساعد في تحسين جودة التوقعات وتحليل السيناريوهات المستقبلية. في عصر الذكاء الاصطناعي يتم التعامل مع البيانات بطرق جديدة تضمن تكاملها ودقتها من خلال خوارزميات متقدمة تعمل على تنظيف البيانات وتصنيفها وتحليلها بشكل تلقائي. هذه التقنيات قادرة على استيعاب البيانات من مصادر متعددة مثل البيانات الضخمة والبيانات غير المهيكلة وكذلك من السجلات الإدارية، مما يتيح للأجهزة الإحصائية القدرة على تقديم رؤى أعمق وأكثر شمولاً. وباستخدام الذكاء الاصطناعي في الأجهزة الإحصائية يمكن تحقيق تحسينات كبيرة في كفاءة العمل وتقليل الأخطاء البشرية، بالإضافة إلى إتاحة الفرصة لإعداد تقارير أكثر تفصيلاً وتخصصاً. كما يفتح هذا المجال آفاق جديدة لتطوير أدوات إحصائية تعتمد على الوقت الفعلي، ويعزز القدرة على اتخاذ قرارات أسرع وأكثر دقة في مجالات مثل الاقتصاد والصحة والتعليم وغيرها. الحضور الكرام، يسعدنا في هذه الجلسة أن نستكشف بعض ما قرأت عليكم الآن من خلال الخبراء الأفاضل الذين سيشاركون في هذه الجلسة. ونبدأ بالسيد مايكل كول من مكتب الإحصاء البريطاني. طبعا السيد مايكل كول هو إحصائي حكومي عمل في الإدارات المختلفة، ويعمل حاليا في مكتب الإحصاء الوطني منذ 2021، ويشغل حاليا منصب رئيس مركز البنية التحتية والتصميم الإحصائي في مديرية المنهجية والجودة في مكتب الإحصاء البريطاني. عمل أيضا كإحصائي في العديد من المناصب والهيئات، ومن ضمنها وزارة العمل والمعاشات التقاعدية وهيئة الإيرادات والجمارك وغيرها من منظمات هيئة الخدمات الصحية الوطنية في أدوار تتعلق بالسياسات والبحوث والتحليل التشغيلي. يتمتع بخبرة في قيادة فرق تحليلية متعددة التخصصات وأبحاث جدوى البيانات الإدارية وتطوير النشر الإحصائي وبناء القدرات الإحصائية. عرض السيد كول سيكون الاستفادة من إمكانية التكرار في إنتاج النظام الإحصائي، فليتفضل مشكورا.
Great, thank you. I'm excited to be here to talk to you a little bit about leverage and reproducibility in the statistical production system on behalf of the Office for National Statistics in the UK. So a lot of you will be familiar with the analytical pipeline, that end-to-end process that tends to produce statistical or analytical outputs. Often has 4 stages, typically follow this sort of pattern, with often starting with a get stage. So that initial starting off part when we're going to get some data that could be held in a big SQL database, it could be held in Excel, it could be held on the web somewhere. That get stage is always the first part, which we're going to talk about today. And then we're going to move through thinking about the next stage in that analytical pipeline process, the analyze stage. So that process of getting that data and trying to get some intelligence out of that data to have some meaningful impact. We then move through to the visualize stage, which is trying to then turn that data that we've managed to gather into something that's going to give some impactful information and leverage the visual side of that to allow us to build a full analysis out and build to leverage that information in a more user-friendly way. And that often ends in a reporting stage. So pulling it all together into, it could be a traditional web HTML report, or it could be a Word file, or it could be a dashboard. And that typical analytical pipeline process exists and is replicated across the world in terms of statistical production processes, but often it is quite manual. It can be broken into steps and obviously quite laborious, and it can take a lot of time. So I'm going to talk a little bit today about bringing reproducibility into that in our work in the UK to produce what we call RAPs, so reproducible analytical pipelines instead. So thinking about how we can build reproducibility into that statistical process, try to move away from that manual process along that journey. And obviously underpinning all of that analytical pipeline is good quality analytical assurance. So making sure that all these steps, as they interact with one another, are built upon a strong quality foundation. And this is a typical release from one of the departments in the UK. So here, the Department of Media, Culture and Sport. And this kind of release is often bespoke. It's often produced quite manually, and often it's done by a team of analysts or statisticians or data scientists. To get to that end, that step, we've gone through all those processes, and that takes a lot of time. And obviously, the more manual steps we put into that process to make the statistical releases, we reduce risk and we reduce quality considerations we need to be mindful of. And from that, we tend to obviously produce a lot of data tables, and pulling those data tables together, again, it is often can be quite a manual process. So here today, I'm going to try to talk a little bit about how we can sort of use code to introduce reproducibility to this process and make it more robust, more transparent for our users as well. So typically, that analytical pipeline involves multiple stages, involves multiple entry points. It often is using proprietary software that isn't always the most open for our users or transparent. So here we've got data being pulled in from a SQL server, data being pulled in from Excel. We're using SPSS, or we could be using SAS, or we could be using R or Python to do some analysis, or we could be using Excel to do some analysis, or we're getting some data tables in. And then traditionally, across the statistical system, that information is going into something like Word, and those data tables are being manually extracting useful narrative or useful numbers out of there to produce statistics, which end up into a PDF or into an HTML website. And what I want to talk about today a little bit is about the alternative to that and how we can use reproducibility to this process instead, using analysis from code to get that point. So here, again, an example from a manual process. So we've got a data table that's being produced, probably from a large database that's then gone through some statistical analysis to make a data table, which then results into a piece of narrative that may be used for communicating that quality statistics out to the public domain. And those figures are lifted from that data table and put into that file. It could be, again, it's very manual, it's very time consuming, it's very laborious. So instead, I want to introduce the concept of doing it in a reproducible analytical pipeline way, so a RAP instead. That's how we refer to it. Because that manual process carries quality risks. That manual process, it reduces a lot of steps in that sequence that as we interact more with data, as we interact more with visualizations, as we interact more with the reporting side, we reduce more steps that reduce risk along that journey. And manual outputs, the traditional analytical pipeline process, take a long time to produce, to assure, to reproduce. And inputs and outputs are not always connected. And I say that those manual steps are a real quality concern for good statistical production processes. And those processes can often be hard to follow. So when we need to quickly redeploy individuals to work on something new, it can be very difficult to rapidly produce statistics of value. And that mentality of copying and pasting or manually removing data or key facts and figures along that way are very difficult and error prone. And it can be hard to make changes quickly or track changes quickly because of a lot of manual processes. So that manual analytical pipeline process is a quality concern. And we often find that there are significant implications when manual steps that may seem trivial or may seem minor go wrong. So this is a famous example from a couple of years ago. The model operated through a series of Excel spreadsheets using manual steps. And in this scenario, it cost JP Morgan and Chase over $6.2 billion. A simple, trivial thing of copying and pasting information between spreadsheets resulted in a massive reputational damage and eroded trust, and in here, a massive financial implication as well. So I want to try to minimize that. Because how is manual analysis checked? Often it's by eyeballing or simply comparing information. It can be sense checks or visual. And repeating that analysis by different people can be done differently every time. And that's what I'm trying to move away from. That's what I'm trying to introduce here in terms of reproducibility. Because reproducibility, it's a growing emerging area in academia. And reproducibility is when we're able to get the same analysis through the same steps and the same data set, constantly producing the same answer. And we, in National Statistics in the UK, we follow the Turing Institute's definition for reproducibility, and we try to make sure we build that into our analysis throughout everything that we do. Because we can't always control the accuracy of our information. We can't always control representative information. That we can always control reproducibility. So reproducibility for us is key. It's a gateway for transparency. It's a gateway for our users understanding what we're doing and for them to be able to reproduce what we put out there in the public domain from statistics. So instead of having a manual analytical process, that analytical pipeline in ONS and across the UK government is moving towards this model instead. So reproducible analytical principles throughout. And that starts really with analysis as code. So we want to try to make sure that our analysis, our statistical outputs, are built from a single code base. And that code base should be one that's written in an open source way. So it's able to be produced externally from us. It should have good version control built to a standard, so using tools such as Git. Embedded documentation, so information related to how we produce those statistics should be embedded in that analysis code, and quality assurance automatically built into there as well. So we're minimizing the manual steps we need to do, and we're taking some of the effort away from quality assurance by doing that automated process along the journey, and it's improving transparency. Because if you've got all our code that's producing our outputs in a single place, and we're not relying on multiple manual steps, we're able to much better ensure that it's transparent of how we got those numbers or those statistics or those visualizations out at the end of the day. And the effect of that, in our view, in our experience, is improving statistical quality, improving trust, and having better business continuity and better knowledge management as well. And often when we show this, it can be difficult to put this into practice. So I wanted to sort of move on to a real example with this. Because this is that same analytical pipeline. So we're getting CSV files in, we're getting data in, we're getting data from web servers in. But instead of having those multiple manual steps, so using SPSS or using Excel or using proprietary software and transferring that information manually across to things like Word or web outputs, we're doing it as a single code pipeline, a single piece of code. So same steps, get, analyze, visualize, and report. But here we're using, example, a Python pipeline to pull it all together in a single place. And it can be hard sometimes to visualize this and get over what we mean by this. So I thought it'd be useful to have an example about putting this into practice. So it could be that we have regular statistical bulletins, regular outputs to report on the economy or other important topics of consideration. And those bulletins can be populated automatically by code along with the charts and tables and documents being generated at the same time. Those data sets that we put out there in the public domain, instead of being manually created, can be done automatically for us as well, validated and built rather than created by an individual or a team. And we can automate quality assurance in that process as well. So we can generate reports on quality assurance that can be done during that run. And that code can be hosted remotely. so version control can be implemented and changes can be made rapidly. But what's that look like in reality? So here on the left-hand side, we've got an example from within the UK school system. So this is from the Department of Education. We've got an R markdown template. That's a piece of code that generates this. That single piece of code will go and look and get the data it needs on a run and pull in the figures that then end up on the right-hand side, which is the output we can see for a particular time period. So we're automating the generation of statistical narrative, we're automating the dissemination of statistical outputs in a way that's much more quality controlled and much more auditable and transparent than would be if it's done manually. And again, just an example of our quality assurance that goes into this space. So again, a single piece of code that is not only generating those outputs in the previous slide, but is doing those quality checks. It's determining if we have the right amount of data to be able to use our outputs for this time period. It's checking that there isn't anything in there that might be a quality concern or any outliers in that space. So what does a reproducible analytical pipeline minimum viable product look like? What does a RAP MVP look like? It's about removing those manual steps. It's about by using open source software as default. It's about building peer review into our methods and code and guaranteeing that audit trail along the way and making that code available to everybody. Being well commented and documented as well. And this is a minimum standard for a reproducible pipeline, but even just moving on and doing one of these steps is a massive step forward in building improved quality and improving transparency in how we produce statistics across any statistical process. In ONS in the UK, we go a bit further than this because we're quite mature in our technical capability and we've been doing this for quite a long time. So we've got an enhanced standard that we work towards, which is linked in the slides as well. But what are the benefits of moving to this way? So, the immediate one is about efficiency. So reproducible analytical pipelines, as opposed to manual statistical production processes, immediately speed up our processing time and our analyst time. And there's massive FT savings that can be made in this process. One example from our office, our quarterly greenhouse statistics production used to take 2 to 4 people 4 to 6 weeks to produce every quarter. So about 240 days over the period. By implementing a reproducible pipeline process instead, that's cut down to 2 people taking 14 days. So a 90% reduction in our time. And that time saving means that analysts and statisticians and data scientists, rather than being involved in manual processes, which can be tedious and boring, can be put to value, driving real benefits to use their statistical analysis on topics of even more greater priority and equally providing more analysis and support to emerging problems as well. There's also massive quality improvements can be gained because well-processed documentation built into code means that our quality assurance is by default. And we can reuse modular components. So we create a single piece of code that produces a statistical output, a quality assurance built in for transparency. We can also use elements of that piece of code to move forward and do other pieces of analysis down the road. And RAPs can even be applied to high-pressure work. So during the pandemic, we were able to rapidly deploy reproducible pipelines to use our COVID statistics. And those bits of code that were modular were then able to be reused going forward for future statistical applications as well. So reproducible pipelines, RAP, brings quick benefits when there's time-consumed analysis that's often very laborious, when we need to improve our resilience and we need to improve transparency, when we need to maximize usefulness of what we're trying to get out, opportunities for collaboration. It works really well when we've got that senior buy-in, when we have time to be able to explore and time to be able to produce this, because it is initially a lot of work to get these things up and running, but when that gain is then paid for forward in time back, it does require a good base level of technical understanding and good coding capability, and it does require a support of community practice, which we've been able to develop across the UK and we're supporting international partners too with as well. It is hard to do when there are limited open tools available, when coding capability may be limited in an organization, and often when reproducible pipelines aren't seen as a positive cultural change. But the gains that can be made from moving in a reproducible way are really clear and really, really powerful. And that ability to be able to automate our statistical production processes in an automated way and free up analysts' time to be spent adding their value and their interpretation of statistical methods is really, really powerful. And I shall pause there. Thank you.
الآن مع السيد بلال قربان من الإحصاء التركي. طبعا بتكون محاضرته اللي هي تسخير الذكاء الاصطناعي والتعلم الآلي لتطوير الإحصاءات الرسمية. السيد بلال هو عالم بيانات متمرس وخبير في الذكاء الاصطناعي، يتولى حاليا قيادة وحدة الذكاء الاصطناعي وتحليل بيانات في معهد الإحصاء التركي. يتمتع بلال بخبرة تجاوز العقدين في مجال الإحصاءات وتحليل البيانات، وكان من رواد تحديث البنية التحتية الإحصائية في تركيا. من الناحية الأكاديمية يحمل بلال درجة الماجستير في علوم البيانات وبكالوريوس في الإحصاء، وعلى مدار مسيرته المهنية قاد بلال العديد من المشاريع المبتكرة التي شملت تنفيذ تحليلات البيانات الضخمة وخوارزميات التعلم الآلي وتطوير أدوات تعمل بنظام الذكاء الاصطناعي لتعزيز العمليات الإحصائية. فليتفضل مشكورا سير بلال. yeah.
Thank you, Chair. Good afternoon, ladies and gentlemen. Thank you very much for having me here today. Today, I'm here to talk to you about the AI experiences of Turkey Statistical Institute. The presentation will be from the perspective of a National Statistical Institute, and I'd like to start my presentation with statistics. This is the proportion of failed AI projects. Because AI and ML projects hold tremendous potential, but they also come with significant challenges. This is the statistics from Gartner. According to Gartner, an astonishing 85% of AI projects fail, often due to unclear goals, poorly defined R&D processes. And additionally, 87% of R&D projects never reach the production phase. And still, the 70% of customers report little or no impact from these initiatives. These statistics underscore the importance of having well-defined objectives, clear project management, and a robust pathway from development to deployment. Without these elements, AI projects are likely to fail, regardless of the technology's potential. The scientific community, as well as the statistical community, focuses on the developing of ML models instead of producing ready-made machine learning products. And as you see at the left-hand side, as is stated in many NSI's National Statistical Institute or National Statistical Offices, this setup is traditionally rely on a structure where a statistician and a software developer handle most of the data and modeling tasks. While effective to a degree, this setup often results in a limited capacity for handling complex ML workflows because these roles are stretched across too many responsibilities. In contrast, an ideal MLOps framework at the right-hand side involves a more specialized and collaborative team. A data engineer focuses on managing and preparing the data, while a data scientist is responsible for developing and fine-tuning ML models, and ML engineer ensures these models are deployed, monitored, and maintained effectively, while a backend engineer manages the necessary infrastructure to support the models. And finally, there should be a DevOps engineer who oversees the CI/CD pipelines to ensure smooth integration and continuous delivery. This division of labor enhances scalability, ensures better performance monitoring, and creates a more robust, automated, and efficient AI operation, which many NSOs could benefit from. And maybe you can't see that much of what I will explain. MLOps is a continuous delivery and automation pipelines in machine learning. According to Microsoft, there are 5 MLOps maturity levels from 0 to 4. This is the level 4. At the foundational level of MLOps, level 0, machine learning processes are entirely manual. This means that everything from data preparation to model deployment is handled by individuals with little or no automation. This level is typical for organizations in the early stages of their AI journey, where models are built and maintained manually. However, this approach is highly time-consuming and prone to human error. As organizations scale, the need for automations become more pressing, which pushes them toward higher levels of MLOps maturity. And this is the level 4. This is the highest level. At the highest level of MLOps maturity, level 4, the process is fully automated, including the retraining of the models. In this stage, machine learning operations are streamlined and automated, which ensures models are continuously updated and improved based on new data. This level represents ideal scenario for organizations aiming to deploy at a scale with minimum human intervention. By automating the retraining process, organizations can ensure their models remain accurate and relevant in dynamic environment where data and circumstances evolve time. To successfully implement AI model in Turkstat, in Turkey Statistical Institute, we follow a structured approach starting from with framing the problem. This involves understanding the data and issue at hand, specifying the purpose, identifying expected results, and preparing working environment. Next, we collect data by identifying potential sources, transferring and exploring data. Once collected, we clean and prepare it, removing errors, handling duplicates, and performing feature engineering. The data is then stored securely with appropriate documentation. Afterward, we choose an algorithm by experimenting with different models, evaluating them based on performance and selecting the best one. And we then train, validate, test, and fine-tune the base model to ensure optimal performance. Once the model is ready, it's moved into production, ensuring all steps are reproducible. Finally, we closely monitor the model's performance, retrain as it necessary, and watch for any deviations in data or in the concept, which ensure it remains accurate and effective over time. And this is our decision map when choosing an algorithm, because when tackling or taking on different types of machine learning problems, we start by identifying the nature of the problem. Depending on the type of the problem, we use the algorithms you see on the slide on the left-hand side. Depending on the interpretability requirements, we might choose simpler models like linear regression or more complex ones like neural networks or deep learning. We consider data science, complexity, and resource constraints. Smaller data sets often work best with decision trees or naive bias, while large and complex data sets might benefit from deep learning or gradient boosting. Of course, if computational resources are available. Because nowadays we have too many, we need to have GPUs, which is like A100 or H100 like that. And as many of you know, Turkstat is responsible producing official statistics for Turkey. Our mission is to provide reliable and timely data that supports evidence-based decision-making at all levels, whether for policymakers or researchers or the public. In recent years, we have seen a paradigm shift in how data is collected, processed, and analyzed. Traditional methods of data collection are no longer sufficient in a world where data is growing exponentially and new technologies are constantly emerging. This is where AI and machine learning comes into the play. At Turkstat, we have adopted this shift by integrating AI and ML into several of our key operations, from automating some of consumer price collection through web scraping and scanner data to using machine learning models for classification tasks. We are actively working to increase the quality and efficiency of our statistics. In this part of presentation, I will walk you through some of the innovative ways we are using ML to improve data collection and analysis. Yes. Traditionally, collecting and analyzing data for official statistics has been a highly manual and labor-intensive work. But with AI, we now have the ability to improve much of this work. For example, data collection processes like price monitoring, which previously relied on field visits or survey, can now partly automate it using web scraping technologies. This allows us to gather data in real time at a scale and speed that would have never been unimaginable just a few years ago. Beyond automation, AI significantly enhances speed and accuracy. ML algorithms can process and analyze vast amounts of data far more efficiently than traditional statistical methods. At Turkstat, we have been benefiting from these capabilities to revolutionize our statistical operations. We have successfully integrated AI to automate data collection, optimize classification tasks, and provide real-time insights. These innovations have not only improved our efficiency, but also increased the quality and depth of statistical data we produce. Yes, one of the key innovations we have implemented at Turkstat is the use of web scraping to enhance collection of data for the Consumer Price Index, or CPI for short. With the rise of e-commerce and the availability of online pricing, web scraping has emerged as a powerful tool for automating this process. At Turkstat, we have developed a system that scrapes price data from various online sources, including websites selling white goods, cars, furniture, clothing, and even bus and flight tickets. Moreover, AI-powered algorithms allows us to predict classification of individual consumption according to purpose, COICOP for short, codes automatically. This ensures consistency and improves the accuracy of data used in CPI calculations. In 2024, web scraping now accounts for 5.1% of total prices used in CPI calculations. This shift to web scraping is a perfect example of how AI can not only increase efficiency, but also enhance the quality of data. And this is, in addition to web scraping, another key technological advancement we have implemented in Turkstat is the use of scanner data for automating price collection in CPI calculations. Because scanner data provides us with detailed sales information directly from the stores. Unlike traditional methods where prices might be recorded manually, scanner data gives us exact prices for all products sold across multiple locations. This high-volume data allows us to calculate more precise price statistics. As of January 2024, scanner data accounts for 42.6% of total price used in our CPI calculations. Another exciting area where Turkstat is using AI is in automating classification tasks using machine learning, because classification is a fundamental aspect of an official statistics and statistical work, whether we are dealing with product categories, occupational codes, activity codes, or other types of classifications. We are using machine learning algorithms to automate the classification of data. We have started developing a classification prediction portal that will support both internal and external users and stakeholders in automating the assignment of classification codes. This portal will help reduce errors and enhance the quality by offering AI-driven recommendations for various types of classifications. And let's turn our attention to the most impactful applications of AI in Turkstat. This is labor market analysis. At Turkstat, we have developed an innovative approach to job vacancy, occupation, and skill classification by integrating administrative data, private sector data, and web scraping data and machine learning models. Our system is designed to predict occupations and skills using deep learning. One of the key benefits of using AI for labor market analysis is the ability to provide real-time, detailed insights into the regional levels. For example, with the BI tools, we can see which occupations and skills are in high demand in different regions, which allows policymakers to make more informed decisions regarding workforce planning and education programs. However, as with all AI applications, there are challenges ensuring the quality of data and fine-tuning the ML models to handle unstructured text into the job description, and this is an ongoing task. But despite these challenges, the use of AI in fast-changing labor market analysis has been really a game changer, which offers more granular and timely data to inform evidence-based decision-making. In addition to AI-driven classification and data collection, one of the more practical applications of AI at Turkstat has been in the use of speech-to-text technology. At Turkstat, we use a general-purpose offline speech recognition model. This is capable of converting spoken language into text with a higher degree of accuracy. One of the unique strengths of our speech-to-text model is that it is multilingual, including support for Turkish, which is crucial for us. Whether we are recording meetings, transcribing speeches, or documenting presentations, the model is able to handle a wide range of languages. And one of the key reasons that we choose this model is this is an offline model because we should maintain data security, because with so much of our work involving sensitive and confidential information, so relying on cloud-based services was not a viable option for us. This offline model ensures that speech data is processed securely within our own infrastructure without any risk of data breaches or unauthorized access. And one of the most ambitious and challenging AI projects we worked on Turkstat was the classification of e-invoice data. Our goal here was to automatically predict harmonized system or customs tariff harmonized code for e-invoices. We have experimented with several machine learning models. These models analyze the product names and descriptions in the e-invoices and attempt to predict the appropriate HS codes. While some ML models have shown success on pre-labeled datasets, we have encountered significant challenges when applying them into real-world e-invoice data. Similarly, we have experimented various LLMs, and including ChatGPT, Anthropic, Cloud, Llama, or others for e-invoice classification. While these models showed promise, there were limitations in terms of accuracy, especially for Turkish language data. Additionally, using online models introduces data security risks, which is a major concern when dealing with sensitive transaction data. In conclusion, while this project has failed and cancelled due to the quality commitment, it has also been a valuable learning experience for us. And we have implemented offline and open source LLMs to enable our staff to use generative AI for tasks involving sensitive and confidential information. Thanks to their offline functionality, these models can be used locally without violating data privacy. Most importantly, no prompts or user interactions are stored in the background, and the data is not reused for retraining the models. This approach ensures that sensitive information remains secure while still allowing for the benefits of AI-powered tools in our organizations. I will skip this because of time limitation and the conclusion. As I reach the conclusion of this presentation, it's clear that AI is no longer the future concept. It is already here, transforming how we collect, process, and analyze data. These technologies are helping us enhance efficiency and improve accuracy, and provide real-time or near to real-time insights that inform crucial policy decisions. And our future vision in Turkstat includes building more robust AI systems, improving our data security, and expanding our use of AI-powered analytics to provide even deeper, more timely insights. In closing, I hope this presentation has given you a clear view of how Turkstat are harnessing the power of AI to drive innovation in official statistics. And that brings me to the end of my presentation. Thank you all for listening.
نشكر السيد بلال على محاضرته أو عرضه القيم. الآن ندعو السيد أحمد عباس من شركة مايكروسوفت. السيد أحمد موجود؟ تفضل الله يسلمك. هو متخصص تكنولوجي ذو خبرة واسعة في علوم البيانات والذكاء الاصطناعي والحلول السحابية. يعمل حاليا كرئيس قسم البيانات والذكاء الاصطناعي في مايكروسوفت، حيث يركز على قطاعات الخدمات العامة والطاقة والطيران. فليتفضل مشكورا.
Assalamu alaikum, everyone. It's a pleasure being here with you today. So today in this session, we're going to be discussing the trends and the impact that AI and generative AI specifically has been having over the past 2 years across all industries in the world, and what Microsoft is doing to leverage these new capabilities in our own products, and how we are working and helping customers in building a framework where they can leverage their data sets properly to make use of LLMs and generative AI in the most optimal manner. So as you're all aware, today we're living in a new AI era. Ever since the release of ChatGPT back in December 2022, almost all industries that we think of today have started embracing AI in a new manner, have started putting in their strategies and their investments buckets specifically for artificial intelligence, as this technology has been transformative to all industries and to different personas as well. So different reports highlight the impact of AI on the growth and GDP for the coming years, and this is and the GCC is no exception to that. We're expecting AI to have a high contribution to the GDP of the Middle East and the countries in the GCC as well. Okay, and the areas that we're realizing where AI is having a great impact, irrespective of the organization or in the industries, are wide. So it comes from enriching employee experiences and boosting the productivities of employees, to reinventing or transforming customer experiences as well, and the way customers interact with our products, customers and partners. It's reinventing business processes and offering us a chance to automate and accelerate how our internal processes are run. And it's opening the door for innovation in manners that previously we didn't even think that were possible. And we're already seeing the impact of that. So a study shows that companies today are realizing 3.5 times ROI for every dollar they're investing in AI. And it's taking typically organizations around 14 months to start realizing the ROI on this investment. Now, this, of course, depends on the maturity of the organization and whether this organization is properly aligning or adhering with a framework that would allow it to reap the benefits of AI in the most optimal manner. Okay. Now, AI is all over the news today, but AI was not, has been available for the past decades. It's not a new technology. So the algorithms that we work with today, that leverages AI have been there since the 1950s, have been envisioned and have been put in place since the 1950s. But only when we started accelerating in first compute capacity, we have enough compute to process these algorithms and run these algorithms. And when we started generating massive amounts of data, this is where we started progressing more and more in AI development. So we moved to having statistical and machine learning algorithms earlier in this decade. In the 2010s, we started seeing deep learning models emerge, speech to text, text to speech, vision models. And lately, with the latest advancements, that's building on top all of the work and advancements that has been happening over the past decades, we've seen the release of generative AI. Now, generative AI is different from the traditional AI that we're used to in many ways. It's moving us from an experience that is, let's call it autopilot, into an experience where users are in control. So AI is no longer only an algorithm that's recommending to you products to purchase based on your preferences on Amazon, for example, or recommending to you, for example, what content you will see on social media. It's become a tool that's at your fingertip and able to serve you in different manners. It no longer only receives data inputs from these applications that we built that are powered with AI. It also generates data output today. So it can generate based on the prompt that I'm giving, whatever data output that is suitable for me also. It no longer just follows command, it also executes. We are part of the process of AI, so it's no longer blindly generating or following commands that are hard-coded in code. It's taking prompts from humans, so we are part of the loop of the AI process. And last but not least, and most importantly, I would say, there is no longer a specialized language for different individuals to work with AI. Previously, you'd have to work with Python, Scala, etc., different specialized language. Today, English is the language of AI, or Arabic, or any language of choice is the language that you use to interrogate with AI, natural language, and this makes AI more accessible to different personas. So as I mentioned, different personas are able to leverage AI, not only data scientists and data engineers, educators, students, research analysts, people with accessibility needs, all of these different personas, given that AI today uses natural language, is able to interrogate with these technologies. So in our world today, every application that anyone interacts with is expected to be an intelligent application integrated with these generative AI capabilities that we're seeing with ChatGPT, for example. This is an expectation from your employees internally, from your partners, from your customers. So this is a new reality where any stakeholder is expecting any application he or she is interacting with to be embedded with AI. And because of that, we as Microsoft have embraced the AI advancements that are happening, and we have decided to leverage these AI so that we can empower every different personas that leverages Microsoft technologies. So Microsoft has been investing in AI over the past decade. We have a lot of patents when it comes to different AI technologies, be it speech, vision, text, natural language processing, etc. But our latest partnership with OpenAI has allowed us to transform every single product offering that we have and embed it with generative AI capabilities, and we're calling it copilots. So you're seeing copilots in your Windows operating system, in your Office 365 applications, be it Word, Excel, Teams. Data engineers and data scientists are also enjoying Copilot experiences with different data-related tools, etc. And our strategy today is not only infusing AI in every single Microsoft offering, but also empowering organizations and customers in embracing this transformative AI journey in their own applications and in their own organizations as well. And we are working on doing it all within while abiding with the responsible AI framework course. So the potential of AI is clear. The question is, what will you build as an organization? How are you going to leverage these capabilities and infuse it in your processes, in your applications, make it accessible to your employees so that they can they reap the benefit of AI? Over the past period and through our experience with leveraging generative AI, we have come up with a framework or a blueprint that any organization can follow in order to properly make use and infuse generative AI capabilities in their applications and in their processes and in the different strategies that they're building. If you look here at the bottom, there are three main criteria that would enable any organization to get started with AI. First, you would need a proper AI infrastructure that would allow you to run whatever AI-enabled application that you're building. Second, you need to have access to foundational AI models, be it proprietary models, open source models. So any of these LLMs that are out there that are published by different organizations, you would need to have access to them. And third, which is most important in this framework, is your data. You need to prepare your data in a proper manner that would make it ready to be consumed by any generative AI or any AI application that you are trying to do. And this is where we will focus today, on how you get your data ready in the era of AI. All right? Because without data, AI becomes an algorithm that doesn't do anything. Now, one of the trends of generative AI today is called retrieval augmented generation, or we're calling it RAG. What RAG means is you have the opportunity to leverage the capabilities of generative AI without you having to train or retrain the AI model. You would take the generative AI model and you would ground it with your data. And this is what we're seeing here in the process here. So if I have any application, for example, that I want to enable it with a ChatGPT-like experience, I wouldn't have to take the LLM and train it on my data and fine-tune it on my data. I'm able to leverage a framework called retrieval augmented generation that does the following. I take any prompt from a user, I go and fetch an answer from a knowledge base that I have prepared. So I have the question and I have an answer. I would come and ask the LLM, given this question and given the answer that I already have in my knowledge base, please generate an answer. The LLM would take the question and the answer from the knowledge base as a context and generate a proper answer. In this process, in this simple workflow, we're not retraining any LLM. We're not spending a lot of money on fine-tuning as LLMs. We're taking the native LLM's capabilities and we're grounding it with our data sets. So an LLM is only able to answer questions related to my data, to my internal, information. Now, to make this possible, this means that the knowledge base on the top right needs to be easily accessible, needs to have relevant data available. You need to have visibility on the data. You need to have data sets not spread in different silos. So you need to have a proper data platform that's able to manage all of these data sets in the knowledge base so that you can then enable your developers or any persona to leverage the capabilities of the native capabilities of the LLM on the data set. And if we look at the market today, almost 99% of all generative AI use cases follow this simple framework, the retrieval augmented generation framework, where they ground the capabilities of the LLM with the data. Okay. So this is just showing the flow. A question comes in. I go and step number 2, I first get the answer of that question from my knowledge base. and then I take the prompt and the knowledge that I have retrieved, send it to the model, I get a response and send it back to the user. And this is a simple framework that any organization can leverage. Okay. Skip that. So in order to empower organizations with the needed data infrastructure to enable this retrieval augmented generation framework, Microsoft has released Microsoft Fabric, our intelligent data platform in the era of AI. Now, Fabric is an end-to-end data platform solution that's able to manage the full life cycle of the data, from data integration and data collection to data engineering to data science to real-time analytics to business intelligence, etc. All governed in a single location that we're calling the One Lake. And the importance of having a platform like this is to be able to leverage the capabilities of the LLMs. You need to have a unified stack where you're able to put all of your disconnected data sources in a single data platform in order to have a generative AI seamlessly built in and seamlessly able to be leveraged on top of the data. Can skip this just for the sake of time. I have a quick demo on Fabric, but I think in the interest of time, we're gonna just skip this. AI. Huh? All right. So Fabric is just one data platform out of many that are available on Microsoft Azure. And this is something that we can discuss together in details after the session. Now, the next important piece of this puzzle, we talked about the knowledge base and the importance of having all of your data properly managed on a knowledge base. The second important piece is having access to these state-of-the-art LLMs. Also, at Microsoft, we are partnering with different LLM vendors, let's say, to make all of these proprietary and open source LLMs available on Microsoft's cloud. So you've probably already heard of Microsoft and OpenAI's partnership, where all of OpenAI's models are trained on Microsoft's cloud and are made available to be consumed on Microsoft cloud. But we're also partnering with others, so Facebook, NVIDIA, and all open source LLMs have become available on Microsoft's cloud. So all of the GPT models that OpenAI has released and has been releasing, all the way to GPT-4o, the multi-modal model, where it has natively, inherently capabilities not only related to text, but also related to speech and vision. So this is why it's called an Omni GPT-4o. By O, it means Omni here. All of these latest models are available on Microsoft Azure, and all of these proprietary and open source model are bundled within one AI solution. We're calling it AI Studio, that would allow your data engineers or data scientists to quickly provision these LLMs and not having to worry about the infrastructure. So we're reducing a lot of operational overheads and making these LLMs accessible to different personas. Okay, and now most importantly, throughout this entire process or framework, where you're preparing your data and where you're accessing these LLMs to start leveraging the power of generative AI, we put strong guardrails on making sure that your data is your data. No one is using your data to retrain any LLMs. No one is using your data to fine-tune any LLMs as well. It's securely protected within your own Azure environment.
Time, Ahmed.
All right. And last but not least, I want to share this screen. If you like, you can take a picture. We're offering curriculums for different personas to get proper skilling and training on AI. Personas could be data engineers, could be data scientists, could be business executives. So we're offering different tracks to get people skilled and ready in the era of AI. And please feel free to take a picture of that. And I can also share it with you after the session. Thank you, everyone.
شكرا سيد أحمد على العرض القيم. الآن ندعو السيد أونور جاقرار من الإحصاء مركز الأبحاث الإحصائية والاقتصادية والاجتماعية والتدريب الدول الإسلامية سسرك. مستر جاقلار.
Thank you, Mr. Chair. Distinguished participants, Assalamu alaikum wa rahmatullahi wa barakatuh. It's my great pleasure to be part of this lively and informative discussions and the panel being organized during the second Doha Data Forum. For those who are not familiar with my organization, I am representing here the Statistical, Socioeconomic Research and Training Center for Islamic Countries, which is the subsidiary organ of the Organization of Islamic Cooperation, based in Ankara, Republic of Turkey. Distinguished participants, in this presentation, at the early stage, I would like to talk and touch upon the evolution of data collection process from the National Statistical Office's perspective. And later on, I would like to touch upon our center's experiences and activities. And lastly, I would like to share with you the early results of the inclination survey that we have circulated among the National Statistical Office of OIC member countries, and hope that the early results will enrich our discussions in further sessions and throughout the Q&A. How can I split it out? Okay, thank you. Distinguished participants, in the early stages of data collection, surveys were conducted primarily through traditional ways, which we call it PAPI, paper and pencil interviewing method. And this method had its own limitations in terms of scope and efficiency. With the introduction of CAPI, computer-assisted personal interview, a new set of requirements has emerged. Interviewers were no longer only responsible for conducting surveys, they also needed to become proficient in using digital devices like tablets and laptops. On the software side, CAPI introduced new demands as well. We needed specialized programs that could handle real-time data entry, automating validation checks, and even GPS tracking for geolocation. Some NSOs developed these solutions internally, but some NSOs outsourced to external stakeholders throughout this process. Next, we have the CATI, computer-assisted telephone interviewing. With the CATI, the requirements evolve once again. From the staffing perspective, the focus shifts to skilled CATI operators who can efficiently manage surveys in call center environment. These operators need not only to conduct interviews, but also manage multiple tasks in a fast-paced setting. On the software side, CATI also requires an integrated system that connects phone operations with survey management software. This ensures that data is entered directly in real time. In terms of hardware, the primary need is robust telecommunication system that can handle multiple simultaneous calls without issues. When it comes to data quality, CATI has shown some advantages in capturing quicker responses, which can enhance data accuracy. However, there might be some challenges as respondents sometimes feel rushed during phone interviews. Despite this, one clear benefit of CATI is the reduction of overall survey costs, making it an attractive option for many organizations. Now let's move to the fourth method, which is the computer-assisted web training, or in short, CAVI. Here, the focus shifts toward web and online design, and marking a significant departure from earlier methods. In terms of staffing, instead of interviewers or call operators, we now need staff who can design user-friendly and engaging web interfaces. These interfaces need to work seamlessly across devices, especially mobile phones, since respondents engage with survey at their convenience, reducing the reliance on human resources. On the software side, CAVI requires advanced online survey platforms that offer a wide range of features like customized layouts, real-time validations, and adaptive questioning. On the hardware side, CAVI its requirements are also different. We need robust servers that can host surveys, manage high traffic, and ensure reliable internet connectivity for users across various locations. Finally, we arrived at the mixed method, and the mixed method brings together all these previous techniques, PAPI, CAPI, CATI, and CAVI. And this method particularly useful for maximizing response rates. And it also allows us to reach respondents through multiple channels, catering to their preferences and improving overall participation. Distinguished participants, national statistical offices increasingly rely on administrative data from institutions like tax records and health systems. This process begins by identifying data sources and securing access through formal agreements like memorandum of understandings. Building infrastructure follows automating data refers via APIs or secure connections like VPNs. Collected data undergoes through validation and quality checks for accuracy and consistency. Secure storage systems with encryption protect sensitive information overseen by data governance specialists to ensure legal compliance. Staffing needs, again in administrative data, needs shift from interviewers to data analysts and IT specialists. NSOs require robust data management systems, automation tools, secure servers, and encryption protocols for efficient handling of administrative data. NSOs also now face the challenge and the opportunity of leveraging big data for innovation in data collection and analysis. First, NSOs must identify the big data sources like mobile phone data, social media, and satellite imagery. Then they must develop a legal and ethical framework to ensure compliance with regulations. Setting up infrastructure, including storage solutions and high-performance computing, is essential, followed by automated data processing and cleaning to handle missing data and transform raw inputs into usable formats. Advanced analytical tools such as machine learning are used to extract insights, and data linkage with traditional sources enhances overall data richness. Ensuring data quality through automated validation and cross-checking is also key. NSOs now handle a variety of data coming from different sources, survey data, administrative data, and big data, and each with its own challenges. The focus has shifted from obtaining data to managing it efficiently through strong data governance. Let's discuss the first, data governance and oversight. The data governance framework establishes a formal structure of managing all types of data. A data governance committee is also responsible for setting policies and regulations for data management across the organization. Data stewards oversee specific data sets, ensuring proper management and quality. Establishing clear data ownership is also essential for accountability and protection of each data set. And lifecycle management is also an important factor, which is crucial in managing data from collection to archival or deletion. NSOs need systems for data integration to combine data from different sources, and data sharing should be secure, enabling collaboration while complying with the regulations. And lastly, capacity building and training. Continuous training is also essential for the NSO staff to keep the staff updated on the data governance policies, management practices, and new technologies. In summary, for effective data governance, 4 key units are really crucial, and these are needed to be followed. When it comes to the requirements across statistical ecosystems, whether dealing with survey data, administrative data, or big data, it differs significantly. For survey data, we primarily need statisticians and trained interviewers, and the software tools typically include platforms like SPSS, and for hardware, we rely on mobile devices for basic servers. Our key stakeholders are survey respondents themselves. For administrative data, we require data scientists and IT specialists, and the software options are more advanced like Oracle. For the big data, we need highly skilled team with expertise in AI and machine learning and data engineering. The software is more complex, utilizing platforms like Python. And now let's explore some of the experiences of our member countries as they adapt to evolving this diverse data landscape. In Indonesia, significant progress has been made in using satellite imagery for poverty mapping. This has allowed them to gather detailed data on remote areas that would otherwise be difficult to achieve. In Malaysia, the Department of Statistics has implemented a trait by enterprise characteristics approach using a fuzzy matching technique. Additionally, Malaysia has launched the public maturity assessment on official statistics, leveraging text mining techniques for sentiment analysis. They also employ Earth observation via satellite imagery, aiding in environmental monitoring and land use assessment. Moving to Turkey, they have employed web scraping by my fellow panelist colleague, web scraping techniques to enhance consumer price data collection. When it comes to my organization's effort in digitalization and assisting OIC member countries' national statistical offices in enhancing their technical capacities and human resources capacities, since 2007, we have implemented 57 activities in the field of digitalization, and these activities mainly focuses on data analysis, big data, and metadata-related topics. And regarding the survey, which we have circulated last August, in order to identify the common interest among our member countries, I just would like to share with you the early results of this questionnaire. When we have a closer look at the early results from the inclination survey that we circulated, one of the key questions that we asked to National Statistical Office of our member countries was, does your institution currently have any digitalization strategies in place? And the response was overwhelmingly positive, with 89% of our member countries' national statistical institutions confirming that they do have digitalization strategies. Another important question that we addressed was, how important is digitalization for your organization? And for this, 56% of the respondents indicated that digitalization is very high importance, and followed by high importance with the 22% rates. We also asked, how would you evaluate the level of digitalization at your institution? Here we see 44% of respondents rated that their level of digitalization is high, while 11% rated is very high. Another key area we explored in the inclination survey was related to security challenges. We asked, what types of security challenges does your institution face? The most common challenge reported by our member countries was technical expertise and skills, noted by 67% by respondents. This was followed by data quality and integrity, and data privacy and security. In addition, we asked, how does your institution ensure the security of statistical data? The majority of institutions, with 89%, reported using access control measures as the primary method. Additionally, regular security audits were conducted by 67% of respondents, and multi-factor authentication is following. Another important aspect we explored in the inclination survey was the artificial intelligence and machine learning capabilities of our member countries' national statistical organizations. One of the key questions we asked was, has your institution begun implementing machine learning and AI technologies in any of its processes or operations? And 56% of the responding NSOs answered yes to this question. We also inquired which areas are AI or machine learning being applied. The two most common areas were predictive modeling and automation of repetitive tasks, both cited by 45% of the respondents. The final area we explored in the inclination survey was the challenges of our member countries in facing in adopting AI and machine learning technologies in their organizations. So we asked, what are the main challenges your institution faces or anticipates facing in adopting machine learning and AI technologies? The most common response at 75% was the lack of technical expertise and high implementation cost. This was not surprising, as many national statistical offices struggle with building the necessary infrastructure and ensuring they have the right technical capacity in our member countries, considering that 21st of our member countries are the least developed countries in the world. We also asked what types of support would be the most beneficial to your organization's digital transformation efforts. All the national statistical offices indicated that they need technical assistance, while 89% pointed that they need training and 65% mentioned that they need funding. And these are some of the impressions from the activities that we organized within the framework of our efforts at our organization. So we continue to put our efforts in order to assist our member countries to develop their human resources capacities at the national statistical offices when it comes to digitalization and the benefits of digitalization in their own operations. Thank you very much for your patience, and I would like to move forward to my place. Thank you.
شكرا سيد أنور جاكلار. الأخوة الأفاضل المحاضرين والمستمعين، طبعا احنا نعتذر منكم عن التأخير ونتيجة الارتباط سواء بالفندق أو بالباقي المحاضرين، فتسمحوا لنا أن ما ناخذ أسئلة في هالجلسة، لأن جات التوجيهات أن تأخرنا كثير. كان المفروض نخلص على الساعة تقريبا 1، لكن تأخرنا كثير في البدء، وأيضا الآن الساعة 1:30. فبعد إذنكم يسمحوا لنا السادة المحاضرين بعد شكرهم جزيل الشكر، وأيضا للمستمعين والحضور على عدم أخذ الأسئلة في هذه الجلسة والجلسة القادمة. والله يعطيكم العافية. شكرا لكم.
شكرا للسيد ناصر صالح المهدي وضيوفه ضيوف الجلسة الثانية من منتدى الدوحة للبيانات. بإمكانكم التواصل المباشر مع ضيوف الجلسة النقاشية الثانية من بعد انتهاء فعاليات أو الجلسات النقاشية لهذا اليوم للإجابة عن استفساراتكم. والآن ندعوكم إلى الجلسة الثالثة والأخيرة لهذا اليوم تحت عنوان تحليل البيانات لخدمة التنمية المستدامة. ويدير الجلسة الأستاذ حفص أبو ملوح، استشاري بحوث وتخطيط في المجلس الوطني للتخطيط، فليتفضل مشكورا.
السلام عليكم. بسم الله الرحمن الرحيم. جلستنا الثالثة والأخيرة، وإن شاء الله أن تكون خفيفة الظل عليكم، تتناول تحليل البيانات لخدمة التنمية المستدامة. كلفت بإدارة هذه الجلسة بالنيابة عن الزميلة فرحة الكواري التي اعتذرت قبل قليل لظرف طارئ، وأيضا نستميحكم عذرا أن نأخذ من وقتكم 15 دقيقة إضافية، ونستأذن من متحدثين أن نختصر الوقت قدر الإمكان. سنعطي لكل ورقة 10 دقائق من حيث المبدأ، وقد تزيد دقيقتين إذا احتاج. فيسرني أن أقدم الورقة الأولى بعنوان تطوير حوكمة البيانات وتكاملها، وسيحدثنا الدكتور محمد عزيز عن التجربة دائرة الإحصاءات في ماليزيا في هذا السياق. والدكتور محمد عزيز هو رئيس دائرة الإحصاء الماليزية، يتمتع بسيرة مهنية لامعة تمتد ل3 عقود، وله مشاركات على المستوى الدولي في هذا السياق، فليتفضل مشكورا.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. And good day, everyone. I would like to start by expressing my heartfelt thanks to the organizing team for their dedication in putting together this remarkable event. It's a privilege to be here and share perspective from the Department of Statistics Malaysia with all of you. Your presence today is greatly appreciated, and I look forward to engaging an insightful conversation. I'm Muhammad Uzair Mahidin, Chief Statistician of Malaysia. This is my a brief structure of my presentation. I cover on a brief introduction of the moderation of the national system in Malaysia, and then I follow with the new data ecosystem and the role of the National Secretary Office. And briefly, I would share about those some agenda in data governance and integration and our recent initiative. Ladies and gentlemen, in principle, modernization of national security system involves adapting to public data agenda. Second, integrated data system as a pillar of data ecosystem, data governance and data strategy, and finally on requirement on the national data infrastructure. In rapidly evolving landscape of digital transformation, National Statistics Office worldwide are undergoing a profound shift in their role and responsibility in terms of data collection, analysis, and dissemination of statistical data, and are now challenged to transcend their conversational boundaries, transforming statistical insight from big data, administrative data, and advanced analytic technologies present unprecedented opportunity to enhance the depth and accuracy of statistical insights. This transformation requires not only a redefinition of the data ecosystem, but also a rigorous establishment of the data governance framework. The key to this evolution is the responsible integration of various data sets while safeguarding the privacy and confidentiality of individual information. As National Security Office embrace this new paradigm, they are tasked with not only harnessing the power of digital data sources, but also ensuring ethical and secure data practices. In these complexities, the role of National Security Office in defining and implementing robust and data governance become paramount. Ladies and gentlemen, among the role of the National Security in this digital era include leveraging big data and administrative data, and also increasing tapping into big data sources, including social media, mobile data, and satellite imagery to enhance their statistical output. Administrative data, utilizing administrative data collected by other government agencies can improve the accuracy and granularity of official statistics. By integrating various data sources, National Security Office can provide more comprehensive and timely information to policymakers, aiding in more informed decision-making process. Improved statistical can enhance the delivery of public services. For example, better data on population demography and health can lead to more targeted and efficient public health intervention. Utilizing advanced analytics, including machine learning, artificial intelligence, can enhance the ability of National Security Office to process and analyze large volume of data efficiently and accurately. Implementing open data platforms such as the Open Document system enhance accessibility and transparency. Through Open Document, researchers, businesses, and the public can access and utilize official statistics, promoting innovation and enabling informed decision making. Ladies and gentlemen, a data ecosystem that evolves through diverse data flows represent a multiple platform and create value from integrated data uses. There are four principles. One is that we have to look data as a service. Data and integrated product can be supplied to users on demand, equipped with answer as a service and information as a service. Second, continuous data aggregation. The ecosystem is constantly evolving with an influx of new data sets, and all data sets will be phased out gradually. Thirdly, from data utility to knowledge hub. Modern ecosystem manifestation include knowledge generation and transfer through AI model, analytical platform, and machine learning algorithm. Fourth, decentralized access through secure exchange. Ecosystem exists regardless of distance or organizational boundary in service-oriented architecture. Statistical agency need to address at least 4 gaps identified to strengthen the data ecosystem. One, on data sourcing gap. Second, data platform gap. Third, analytic gap. And fourth, mandate gap. Ladies and gentlemen, as we move into era where data drive every decision, the Department of Statistics Malaysia is taking proactive steps to solidify its role as a national leader in statistical system. Let me highlight some key action that Department of Statistics Malaysia is currently undertaking to ensure we meet and exceed the expectation. One, agile in statistics. DOSM is committed to being responsive and flexible in our approach to statistics. We are constantly adapting to the changing demand for data, ensuring timely, relevant, and accurate information that keep pace with the nation needs. Leading the expectation as an statistical office, we are not just fulfilling current data needs, but also must able to anticipating the future. Department of Statistics is setting new benchmark in data quality and accessibility, raising the standard for the national services across the board. As a part of the early warning system, we recognize that there are unforeseen challenges when integrating vast amount of data, but Department of Statistics Malaysia is prepared. For example, Department of Statistics Malaysia proactive in SC government in the preparing in the input on advanced estimate for GDP, looking at issue on the aging, the productivity, and decent cost of living. Leveraging cutting-edge technology, DOSM is incorporating AI, big data analytics, and cloud computing into our system. This will allow us to enhance our data capabilities, ensuring faster processing, deeper insight, and improved accuracy for decision makers. Whether it's amnesty data from various government agencies or harnessing the latest advancement in technology, the department is capitalizing on every available data source. This allows us to enrich our statistics and provide a more comprehensive picture of the national trend and challenges. Let me share some issues that keep coming in any country. This is some issue in Malaysia. For example, how to statistic can assist on the ensure this price stability. How we can really have a system can detect the economic recession, and more important in how we can reduce the income inequality. We have to look at not only at the national level, but also by location and also income group. And of course, we have to assist the government how to attract more potential investor and how to increase productivity to support the sustainable growth, how poor environmental quality and affect public health, how to reach a decent well-being condition. That's the among others, and of course, with the strengthening our capability, we need do more and look at what the latest analytical can be offered to our stakeholders. On the Department of Statistics agenda on the data governance integration, we can see that our role is not only providing table after table, numbers after numbers, but we need to provide our leadership with our colleague from other government agencies, because we know that the statistics not only reside at National Statistical Office, but also we have a lot of the opportunity where the data is reside with the other government agency. So we need to provide the leadership, and we have to take every challenge as the opportunity. It's not easy, especially when the other government agency is not really follow the national security framework in terms of methodology and also the conceptual. And of course, with the similar program like this and exchange idea and knowledge among our colleagues from the global perspective, any difficulty or the hardship in modernizing and keep up to the expectation, I think we not necessarily have to reinvent the wheel. We can really have the good collaboration and have also exchange ideas among our colleagues. So this how Department of Statistics try our best to fulfill our role, especially to manage the expectation and how we can step in to bring so many statistics, so many opportunity out there with the right technology. So we have the capability, I believe, as the National Security Office to be a data stewardship. So we do a lot of engagement with others, government agency and our stakeholders. Yeah, this is how we carry out our responsibility. So we've already set up our National Statistic Data Council at the higher level, chaired by our Honorable Deputy Prime Ministers, and we also come up with a person who can handle the discipline in statistics in other government agency. And in terms of data integration, I would like to share here among the latest data integration be done by Department of State, like for example, Center Database, Malaysia Statistic Population Profile, birth and death data, married and divorce data, labor market analytic platform, informal sector and micro industry database. This among the activity that done by the Department of Statistics. For example, if you want to convey the message issue on the aging society, we need to put all the information in one dashboard. Then people at large can understand, not only the government or the policy makers. And is the reason activity, for example, when we carry out the agriculture census, we need to bring people together to understand the importance of agriculture census, and did the latest activity where we work together with our ministry on having the central database for every single individual, single household in the country. Is a very big exercise, and if anyone want to get more on this, we can give some explanation. It's cover on social, on the background, on education, and profile or demography. So this will give the powerful tool for for the government to execute any program with the right and timely socio-economic profile of the people. So with that, thank you very much. Sir.
شكرا دكتور محمد على هذا العرض. وورقتنا الثانية حول التقدم المحرز في تحقيق أهداف التنمية المستدامة في الدول الأعضاء في البنك الإسلامي للتنمية. يحدثنا عن التحديات والفرص الدكتور عارف أودنكو، وهو الذي يشغل منصب خبير اقتصادي أول في البنك، وتشمل اهتماماته البحثية التحديات والفرص المتعلقة بالتنمية الاجتماعية. فليتفضل مشكورا دكتور، ونستأذنه أن يكون لمدة 10 دقائق.
Okay. How does it go back? Assalamu alaikum, everyone, and good afternoon. First, I would like to thank you. Good. First, I would like to thank Qatar National Planning Council for bringing us here together for the Doha Data Forum. I hope it's going to be very fruitful in 2-day event, and we will discuss and we will get very good results at the end of the meeting. I work for the Islamic Development Bank, and we have like 57 member countries, and we help our member countries through projects and interventions. And during these ones, we use like our data-driven analysis and results. And so these like data-driven results are very helpful for us to decide what kind of projects in which countries, in which states it will be helpful. And today I'm going to present our annual flagship SDG report and like how our member countries progressed in this SDG, Sustainable Development Goals agenda, and how this data is helpful and what could like we interfere from that. So this is my outline. First, I'm going to give the overview. Then we look at the global SDG, the averages, and how the SDGs are doing globally. Then I'm going to give information about the ISDB average, and then I'm going to touch upon the most challenging and best performing SDGs of our member countries. And I'm going to show a profile, one of the member countries, and which we do like for our each 57 countries. And then how our countries perform in these real results. Then I conclude. So as we all know, the SDGs, the 17 SDG goals was adopted in 2015 in the United Nations to give the agenda, the global agenda for the upcoming 15 years. So by 2030, it's going to be the end of our agenda, and the main motto is "No one leave behind." So in these SDG goals, how the countries are performed and what could be achieved. They are very ambitious goals, and there are like 17 of them. But there are also many indicators. And this report, we grouped them in the 5 categories. And in like very unsatisfactory, satisfactory, moderate, satisfactory, and then very satisfactory, and from like red to green, as you see. And we look at the show of the progress just this year also, and we look at the trends and how like the countries are doing, whether it's going in the right direction or wrong direction. So as I said, there's also we have the SDG trends, and there's like we compare them. We look at from the data for the most recent 5-year data, and look at the annual growth rate, and compare with it to do forecasts by 2030, whether the countries can achieve the targets or not, or even maybe they are going the wrong direction, which means the red one, decreasing one. The countries might have stagnating, so just the data is there and it's not progressing. It could moderately increasing, but it means it will not achieve the targets by the end of the 2030, indicated by the yellow line. And the green lines means whether already the country is achieved or it's on track. So if it goes this way, the country will achieve the targets by the end of the 2030. And as you always do, there's sometimes data problems and sometimes the information not available, and it's to double grade that. So in the 17 SDGs, we put in also 5 Ps. It's like we have like the 5 category. Like people category is like we are dealing with the no poverty, zero hunger, and it's all about related with the people to achieve a life in dignity. And we have planet dimension. In the planet dimension, it's about our world and how we protect them. So like climate action and life below water, life on land, they're all grouped in here. We have the prosperity dimension, and prosperity dimension is give the human beings the prosperous life and how the indicators are doing in that dimension. We have the peace one, so it's like includes like the foster the peace in an inclusive way. And partnership is the last but not the least, and it always reminds us we can achieve this one only we can cooperate, all of the like institutions and the government agencies, all international organizations. Unless we don't partner, we cannot achieve these all the targets. So if we have look at the global SDG average, it is 66.3%. So we have much more way to achieve by 2030. But the progress is most stagnating. So these are the bad news, and it is very difficult to achieve by 2030 if we go this way. And even there are some SDGs, some goals, the trend is decreasing. So it is in the wrong direction. And the remaining one are stagnating. And the decreasing one like SDG 0 hunger, SDG 3 good health and well-being, SDG 11, SDG 14, SDG 15, and SDG 16. So those 6 of them, the progress is decreasing. It is in the wrong direction. When we look at our ISDB average, it is less than the global average, but not much. It is only like about 4 percentage points. So ISDB average is 62.1. So we are slightly over than 60%. When we look at the 5 Ps, the most challenge is on the peace dimension. And our member countries are perform relatively well on the planet dimension. So this is mainly driven by the SDG 12 climate action and SDG 12 responsible consumption and SDG 13 climate action, which I'm going to show more data about that. So this is the ISDB average for each 17 goals. As I said, like there are 2 SDGs. Our member countries are doing very well, SDG 12 and SDG 13. The good news is there aren't any SDGs in the unsatisfactory one, so less than 40%. But there are still about 9 of them is between 40 and 60% performance rate. So if you look at the most challenging and best performing SDGs for our ISDB average, SDG 5, gender equality, is the most challenging one this year. This is the problem about like the women and gender inequality issues. And we can, like as an ISDB, we are very involved in the like the women empowerment and putting more efforts and more intervention to countries. Hopefully we will have better results with the gender equality dimension. The second most challenging one is SDG 9, industry, innovation and industry. This is mainly driven by our member countries are in their early development stages. And so there is like more projects needed for especially for infrastructure and industry. And as a soft power, also as a ISDB, we should try to invest more in their innovation capacity. our member countries are doing relatively well in SDG 13 and SDG 12. These are two main options because, as I said, our member countries are in early development stages, so the nature is more preserved, and so there is like these indicators, these goals are much have better results. But there's also maybe another problem might be the data issue here because these are relatively new areas, and the data are not that much solid in that sense. Okay, just one more minute. So I just showed like the one our member profile, Afghanistan. As you see in our reports, we look at our each member countries, and in our international projects, we use this one. For example, for Afghanistan, SDG 1 is like very low, so we try more focus on when we are intervening the country in the projects. These are like how our member country is doing. So the green ones are like much better in that sense, and the red ones are have lower SDG scores. So in conclusion, as I said, as global SDG is also the progress is very slow, and so most of the SDGs are stagnated, and even some of them are decreasing. With compared to global agenda, ISDB average is close but lesser. We have a long road to achieve SDGs by 2030. The good news is we don't have any member countries MC could be considered satisfactory. It means below 40%, but still, like we have 22 member countries have below 60%. They are not in the satisfactory area yet. So there's a wide difference in challenges in among the SDGs and MC member countries. The most challenging one, SDG 5, again, gender equality. So it shows the gender gap, and there's a need for women empowerment. The second most challenging one is the SDG 9, industry, innovation, and infrastructure. And it's like the vital SDGs for the sustainable development. But as I said, like SDG 12 and SDG 13, ISDB member countries are doing much better. And so at the end, ISDB has a significant role in supporting these member countries. And we use like these data-driven results to help our member countries to have like the related projects in and intervening them in a more helpful environment. And thank you so much again, and have a wonderful day.
شكرا دكتور عارف. لوحتنا الأخيرة لهذه الجلسة ستكون حول استخدام منصة أهداف التنمية المستدامة المفتوحة المصدر لإنشاء منصات إبلاغ وطنية لبيانات أهداف التنمية المستدامة. تحدثنا مستشارة السياسة الدولية في هيئة الإحصاء البريطانية السيدة سارة فيليبس حول هذا الموضوع، وهي مستشارة دولية خبيرة شاركت في العديد من المشاريع الدولية في المكتب الأوروبي للإحصاءات، ولها خبرة في مشروع شبكة المعلومات الإلكترونية للنظام الإحصائي، وأيضا تمتلك خبرة واسعة لمن أحب في تنفيذ حملات تسويقية والتواصل الفعال في قطاع الرحلات البحرية والسفر كمان، يعني في نهاية هذا اليوم لمن أحب. شكرا دكتورة، تفضلي.
This is the next, and this is the thank you. Okay, good afternoon, everybody. Let's see if I can get this all done in 10 minutes. Okay, so the presentation I'm going to do this afternoon is about the Open SDG platform that ONS has developed. We're going to show you how it works. Really high level, not going into any depth at all, but it will just give you a taster. And we'll also provide you contact details for those of you who are interested in joining us with it. Okay, right. So as the lovely gentleman said before, there are 17 goals, and we kind of look more at the people, planet, prosperity, peace, and partnerships. They aim to measure, the platform aims to measure performance and progress towards these goals. And it will show you what your targets are and what the indicators are. Okay, so the whole idea behind the platform is that it helps report your progress towards the goals by collecting and measuring and analysing your data. All can understand these goals, all can understand the reports, so therefore you can all see where you're going and where you actually need to put your efforts. It's leveraging established sustainability reporting and standards and principles, if I can talk, by reporting data to help focus decision making. This helps delve further into the complexity of some of the issues. And this also empowers everybody to taking action, changing your strategy where it needs to be changes, and it will empower everything. In summary, the SDG reporting empowers stakeholders to act, adjust strategy, and work to achieve the goals. Okay. Many countries and organisations have the data to help see how they're getting on with their SDG goals, but they just might not be able to interpret it. This is where the platform actually comes into its own. It's a template platform. It works on, what can I say? Sorry, it's an open platform that you and users can customize it so you can change it around to make it work for you, show you what you want to see and how to interpret your data. The image you can see up there is the UK version, but again, as I said, you can create your own version. We can have it interpreted into your own language. We do have quite a few languages already on board, but we can also have the ability to take on a lot more. So basically, this would be your platform done your way, providing the information that you want it to provide. Some of the key features for the platform is, as I said, any language. It uploads SDMX. The data can be visualized in maps, tables, and charts. You can break down the data. For example, you could break it down into gender, into age. So depending upon what your needs are or what you want to see. It has been created with the user at its center. And it's designed with accessibility in mind. So yes, at the moment it's designed to the UK standard, but that doesn't mean that we're the best standard, but there's plenty more out there that we can change to help you work with it. It's managed through GitHub and it's supported by the open source community. Currently, over 55 countries, regions and organisations use the Open SDG. ONS works closely with many of the countries to get their platforms set up and reporting their SDG data. And you can see by the map and some of the splodgy colours on there who we're actually working with. So how can we help you? We maintain and develop the Open SDG as a platform for all users. We will provide written and video guidance for all users. We provide additional assistance where needed, able to extensively support some countries through international development team. We will also come out and provide virtual help, and also at times we will come and visit you and help you with it as well. So basically, we're a one-stop shop. We'll help you wherever we can. We collaborate with other statistical organisations to improve the Open SDG and the National Statistical Office reporting, including the United Nations Statistical Division. Part of the SDMX SDG working group is run by the UNSD. Okay, we've recently been out to Africa and we worked with 7 different countries in connection with the UN, and we've got them up and running on the platform. The UNSD delivered the training on the SDMX, and ONS delivered the training on the Open SDG. All participants have set up their national reporting platforms now, and they're up and running, and they found it a real good tool for them to use. And it's, as I said, we're developing at all times. So if you are interested in getting involved in it, or you have some more questions, because this has been a real whistle top tour, because I know we're really short on time, they're the contact details. Okay, and thank you for your time.
شكرا دكتورة، وأعتقد أنه أمامنا 5 دقائق يعني من الوقت اللي أتيح لنا، فممكن ناخذ سؤال لكل متحدث، سؤال واحد، والبقية بتكون أثناء الاستراحة إذا رغبتم. في أسئلة أو حد بحب يسأل المتحدثين سؤال؟ طيب، إذا نشكركم على هذه الجلسة، نشكر المتحدثين، نشكركم على حسن الاستماع، ونترك المجال للدكتور للإغلاق.
شكرا الأستاذ حفص أبو ملوح، استشاري بحوث وتخطيط في المجلس الوطني للتخطيط، وأيضا الشكر موصول لضيوفك الكرام. الحضور الكريم، وصلنا وإياكم إلى ختام يومنا الأول من منتدى الدوحة للبيانات من أجل الابتكار في التنمية المستدامة. شكرا لحضوركم الكريم، ونلقاكم غدا الساعة 8:30 صباحا، وندعوكم إلى تناول وجبة الغداء في الطابق العلوي. شكرا جزيلا لكم، والسلام عليكم ورحمة الله تعالى وبركاته.